Hello everyone, welcome to OHM Institute. I am Surendra Reddy, faculty for electrical machines at OHM Institute, Hyderabad. So, as most of you, as the title of the video itself is explaining, so this particular video we will be covering the entire 2019 AP TRANSCO question paper. Okay, so that is Assistant Executive Engineer exam conducted in 2019. Electrical engineering complete paper we are going to discuss, and I am available with all the faculty members of the OHM Institute. Subject by subject we will discuss the questions, also the detailed solutions. Okay, so as everybody knows that very soon we are going to expect notification in Andhra Pradesh state. We have various news articles earlier also. The file has been approved by the chief minister, so any moment we can expect a notification from Andhra Pradesh Power Sector Department. Okay, so we are expecting the notification from TRANSCO and also DISCOMs. All the three DISCOMs, okay, are going to release the notifications. So we don't know yet whether they will conduct one combined exam or individual exams. We don't have information so far, but definitely notification is around the corners. Okay, so as most of the students are already gearing up their for the exam, also they are rigorously preparing for this exam. So from OHM Institute we would like to help you what is going to be the pattern of the question paper that you can expect. So for that purpose we are taking the previous papers. This is going to be the first video in this series, and many videos are going to come up with many of the previous paper solutions. Okay, see what is the advantage of solving a previous year examination paper. See, any competitive examination, what is the model of the questions they are framing, okay, at what depth they will ask the questions, okay, at what level we need to prepare, what are the topics to be covered, what is the subject wise weightage. All these things you can understand only when you go through the previous question papers, right? So in this regard we will be discussing about the solutions of all the previous question papers. At least 5 to 6 papers we would like to solve, and this is going to be the first in the series. Okay, all right, I have with me all the faculty members. Subject by subject we are going to discuss the video solutions. And before moving to the actual discussion, I would like to show you the subject wise weightage for this particular exam in the year 2019. Okay, you can see here yes, I have segregated subject wise weightage. Okay, from electrical circuits we got 12 questions in the year 2019. Okay, from electrical circuits 12 questions and from electrical machines subject we got 12 questions. Power systems carried 13 questions. Power electronics carried 12 questions. Control systems carried 8 questions. You can understand from the technical subjects, from the core subjects, this is the highest weightage. Okay, these 5 subjects are carrying the highest weightage: electrical circuits, electrical machines, power systems, power electronics, and control systems. Okay, and we have other subjects. From analog electronics we got 1 question. Gautam sir is going to discuss about the solution of that particular question. Digital electronics we have 2 questions. Hemant sir will be dealing that particular subject. Measurements we have 5 questions, okay, overall together. And the utilization of electrical energy, see in 2019 question paper, in that notification UEE is also a part of the syllabus. EMF is excluded, signals and system is excluded, mathematics is also excluded. Okay, yes. And microprocessor also we got 1 question. You write any state level services examination, minimum 1 question will come from microprocessor. You take all the 5-6 previous papers, 1 question will at least come from microprocessor subject. Okay, and then 3-phase circuits. See, at OHM Institute we don't club 3-phase circuits with electrical circuits. We will always deal with electrical circuits as a separate subject and 3-phase circuits as a separate subject. Okay, yes. And then the general studies paper, I must say aptitude and general English together is going to carry 30 marks. Okay, that means if you look at yes, if you look at the technical subjects, all the technical subjects together will carry 70 marks. Okay, and the general studies part the general studies doesn't mean general knowledge. They don't ask you any current affairs or history, geography kind of things. It's just about aptitude and general English. Okay, it will carry 30 marks weightage. So overall, the exam is conducted for 100 marks and 120 minutes duration. Okay, so we will be discussing each and every subject along with the video solutions. Okay, and I'll be starting with electrical machines subject. Understand? Okay, so watch the video till the end. Okay, and if you wanted to solve the question, any question on your own, you better pause the video, try on your own. Okay, the question will be displayed on the screen. First pause the video, try the solution on your own, and if you did not get the answer, then I recommend you to watch the video completely. All right, yes. So let's start with the electrical machines as the first subject. As I rightly said, we have 12 questions from electrical machines subject. So let's see the first question. Okay, this is actually question number 48 in the question paper. Okay, in the entire question paper. Yes, read the question. An 8-pole DC generator has a simplex wave-wound armature containing 32 coils of 6 turns each. If flux per pole is 0.06 Webers, the machine is running at 250 RPM. What is the induced armature voltage would be? That is the question. Okay. So see, options are, if you look at the options, they are very near to each other or deviation is there. Yes, they are not close to each other, right? That means even approximate calculations also can give you the right answer. Nearest answer you can select. They are not very close to each other. All right. So that's what is important. So let's understand the question is from which subject. It is from DC machines and the topic is EMF equation. It is from the EMF equation of a DC generator. Okay, so let's understand what are the crucial informations given in the problem. It was an 8-pole machine, number of poles were given and it has simplex wave wound armature. See, armature windings are two types. It's wave winding and lap winding, and given is a simplex wave winding, and it has 32 coils are there, and every coil has 6 turns. Overall 32 coils are available in the machine and every coil has 6 turns. Flux per pole is 0.06 Webers. Machine is running at 250 RPM. What is the induced EMF is the question. Yes, I hope most of you know the generated EMF formula of a DC generator. EG is equal to Z by A into P phi N by 60, correct? Okay. So in this equation, Z indicates the number of conductors. But in the question, number of conductors were not given directly, but a number of coils are given. There are 32 coils. Every coil has 6 turns. And then what is the number of conductors? We know number of conductors Z is equal to, yes, there are 32 coils. 32 coils are there. And every coil has 6 turns. And we all know a turn means how many conductors will be there? 2 conductors will be there, right? So how does a turn looks like? Yes, this is how a turn looks like. Okay, and this turn consists of 2 conductors. Okay, this is one conductor in the turn and this is the other conductor in the turn. A turn will have 2 conductors. Like that, there are 6 turns in every coil. Like that, overall 32 coils are there. So Z is equal to 32 into 6 into 2 divided by A indicates number of parallel paths. So number of parallel paths will depend upon the type of winding we are using, and here they are using wave winding armature. Therefore, number of parallel paths are going to be 2. If it is lap winding, number of parallel paths are going to be equal to number of poles, correct? Okay. And how many poles are there? 8 poles are there. And what is the flux per pole given? 0.06. 0.06. And what is the speed of the machine? Yes, the speed of the machine 250 RPM. 250 RPM divided by 60. Okay. And if I complete this solution, I will get the answer for the induced EMF. Okay. Remember, this is an exam where calculator is not involved. So you try to answer on your own. Okay. Just to make a simple calculations. 2 and 2 will be cancelled. 6 will cancel for 10 times here. 10 will cancel for 20 times, 25 times here. So the answer is 32 into 8 into 0.06 into 25. Am I correct? Okay. So the nearest answer you can select, we will get 384. See, don't try to use calculator here. It's a very simple calculation. 8 into 25. Is it not 200? 200 into 32. Is it not 6,400? 6,400 into 0.04. That is 64 into 6. 384. Okay. So the nearest answer you can select. The answer is 384 volt. It's a simple question. Okay. Right. Let's see. We have one more question from DC machines in AP Transco 2019 paper. A 220 volt, 10 kilowatt, 900 RPM separately excited DC motor has an armature resistance of 0.02 ohm. When a motor operates at rated speed and with rated terminal voltage, the electromagnetic torque developed by the motor is 70 Newton meter. Neglecting the rotational losses of the machine, what is the current drawn by the motor from 220 volt supply is the question. First of all, it is a separately excited motor. Armature resistance was given. Motor operates at rated speed with rated terminal voltage. Electromagnetic torque was given. What is the torque value? 70 Newton meter. Neglecting the rotational losses of the machine, what is the current drawn by the motor is the question. Look at the options. Okay, we have to choose what is going to be the correct answer. See, in the given question, the torque information is given to you, right? Yes. What is the torque developed by the machine? It is 70 Newton meter. Also, motor operates at rated speed. This is very clearly given, rated speed, and rated speed was already available on the nameplate details. Okay, the speed is equal to 900 RPM. The supply voltage was 220. So first of all, let's note down the information given. See, the torque developed by the machine is 70 Newton meter. Speed is equal to 900 RPM. See, the moment I have a torque and speed with me, I can calculate the power developed by the machine also. Yes. What is the formula for power developed by the machine? That is 2 pi nt divided by 60. So therefore, it is 2 pi by 60 into n is 900 RPM. Torque was 70 Newton meter. Okay. Leave it like this. Okay. So it is 2 pi into 900 into 70 divided by 60. This is the power value. But the information that we need is what is the current drawn by the motor. So the moment you know power value, we have one more formula for power developed by DC motor, that is back EMF into armature current. This is one more formula for power developed by a separately excited DC motor. Okay, already we have power value with us. Now the question is to calculate the current information. So to calculate the current information, I have to find out the back EMF of the motor, right? Okay, what is the formula for back EMF? Back EMF is equal to Vt minus Ia into Ra. This is one formula. We have one more formula for back EMF. What is that? Back EMF is equal to Ka phi into omega. This is another formula, correct? So what I can do here, which formula is going to be useful? Just pause the video and try this question for a while, and then you will get the answer. If you did not get any answer, then continue the video for the solution. All right. All right. So now let us see how to answer this question. See, the point is we have the power value with us. So let's simplify this so that I can proceed further. 2 pi by 60. So during your preparation, you might have learned this ratio. This is very, very important ratio, so that you can easily convert RPM to radian per second. See, 2 pi by 60 is equal to 0.108. 0.108 can be approximately treated as 0.1. If it is 0.1 into 900 into 70, 0.1 into 900, it will become 90. So it will become 6,300 watt. Strictly speaking, it will be more than 6300 watt. Why? Because this ratio is exactly 0.108. Now you may question me, sir, how do I remember this value is 0.108 in exam? Because this is the repeated calculation. So to convert RPM to radian per second or radian per second to RPM, this ratio is very important. 2 pi by 60, 0.108, approximately 0.1. Therefore, the power is 6300 watt. I can substitute that power here. Let us substitute this back EMF in this equation. Then I will go to the next page. Yes. Power is equal to EB into IA, and EB is equal to VT minus IA into RA into IA. This is the power. Power is already 6300. Terminal voltage was 220 minus armature current we don't know, but armature resistance we know, right? Armature resistance was given in the problem. How much? 0.02, very small, into IA. Now, if you wanted to solve the question very quickly, you can take one approximation here. The approximation is, see, armature resistance is very small or very large? Very small. Okay, as the resistance is very small, let us neglect this IA RA drop, so that I will get approximate answer. And I can choose the nearest option that will give me the solution very quickly. But if you want exact answer, you consider this IA RA drop also. You will get the answer, but it will take a bit of time. Okay, maybe 10-20 seconds extra time is required. Okay, remember armature resistance 0.02. And you see the options, the currents are in the range of 30, 20 like that. Okay, so even if the current is 30, 20 or 40 something like that, the resistance drop is usually very, very small. That drop I am neglecting so that I can get the answer quickly. Okay, this is smart calculations, guys. Okay, if you are able to implement these kind of smart calculations, you can answer questions very quickly and you can save a lot of time in the examination hall. And any approximation you are taking, that must be valid approximation. Neglecting IA RA drop is a valid approximation since RA is very small. Okay, so just neglect it. Then 6300 is equal to 220 into IA. So from that, IA is equal to 6300 by 220. 0 will cancel. It will be 630 by 22. That means 3 times 6, 1, 5. 315 by 11. 315 by 11 is approximately 315 by 10. If I take it as a 10, I will get 31.5. Exact answer will be less than 31.5. Correct answer. Okay. So if I assume it as a 10, denominator as a 10, then the answer is 31.5. But actually this is not 10, this is 11. 11 means you will get less than 31.5. So what is the answer which is less than 31.5? Yes, 30. Less than 31.5 is 30. So that is the answer for this question. It is a separately excited DC motor. Torque value was given. Machine is also rotating at rated speed. So rated speed was 900 RPM. Okay. Easy question. So the approximate answer is 30 ampere. All right. So let's move to the next problem. This is a question we got in 2019 AP TRANSCO paper. The question is from transformers subject. Okay, so I recommend everybody please pause the video and read the question first of all. Okay, right. A single phase transformer has a turns ratio of 1:2 and is connected to a purely resistive load as shown in the figure. The magnetizing current as well as the load current drawn is 1 ampere. If the core losses and leakage reactances are neglected, what is the primary current is going to be? Okay, yes. See that transformer diagram was very clearly given. It is a 1:2 ratio transformer. Secondary side current was given. This is 1 ampere. I must say this is I2. Also, you can see the load is a resistive load. Am I right? As it is resistive load, the current will be in phase with voltage. That's why I2 is equal to 1 at an angle 0. Now, what is the primary current is the question, I1. So, those who studied the complete, operation of a transformer, you know that primary current I1 will have two components in it, right? So, I1 will have two components in it. That is no load current I naught. Another one is load component current I1 dash. Again, this no load current I naught will have again two components in it. One is magnetizing current I mu. Another one is core loss component current IW. And then finally we have load component I1 dash. In the given question, magnetizing current is 1 ampere, I think. Yes, where is the magnetizing current given? A single phase transformer has a turns ratio 1:1 and is connected to a purely resistive load as shown in the figure. Yes, the magnetizing current as well as the load component current, both are 1 ampere only. Yes, so magnetizing current is also 1 ampere. See, magnetizing current is 1 ampere. But important thing is angle. It's an AC circuit. We can't add the currents algebraically. We have to add them vectorially. Yes, we know magnetizing current is a purely active component or reactive component. Reactive component, and it will lag the voltage by 90 degrees. So therefore it is 1 at an angle minus 90 degrees. Next, loss component current is neglected in the question. Why? It is clearly given core losses and leakage reactances are neglected. Understand? Okay. Yes, that's why loss component current is 0. Now coming to this load component current, we know I1 dash will be equal to K times of I2. Okay. So let us continue. 1 at an angle minus 90 degrees plus what is K? K is always equal to N2 by N1. We call it as transformation ratio. Transformation ratio. Okay. So 1 at an angle minus 90 degrees plus what is the N2 by N1? 2 by 1. It is 2 by 1 into I2 was 1 at an angle 0. So it will be finally 1 at an angle minus 90 degrees plus 2 at an angle 0. So see, one phasor is at an angle 0, another phasor is at an angle minus 90. So can I say magnitude is vectorial summation? Yes, it will be square root of 1 square plus 2 square. It will be root 5. Root 5 means just more than 2. Root 4 is 2. Root 5 will be more than 2. So the answer which is more than 2 is the correct 2.24. Okay, it's again a simple question. Yes, any question, pause the video, try on your own first, and then if you did not get the idea, then resume the video and watch the solution. Understand? Yes. All right, let's move to the next problem. Yes, we have one more question from transformers subject. This is from voltage regulation topic. I think I forgot to mention the topic of the previous problem. This particular question is from the equivalent circuit of a transformer. Okay, this particular question, the topic is equivalent circuit of a transformer. So those who studied about the equivalent circuit, they must be able to answer the question easily. The next question, this is voltage regulation of a transformer. The topic is from voltage regulation. Okay, so request everybody just read the problem, pause the video and read the problem thoroughly, then resume the video. Yes, read the problem. A single phase 100 kVA 1000 by 100 volt 50 Hz transformer has a voltage drop of 5% across its series impedance at full load. Of this, 3% is due to the resistance. The percentage regulation of the transformer at full load with 0.8 lagging power factor is how much? Okay, we are asked to find out what is the percentage regulation, that too at full load and with 0.8 lagging power factor. First of all, what is the formula for percentage voltage regulation? Percentage voltage regulation is equal to percentage resistance into load power factor cos phi 2 plus or minus percentage reactance into sin phi 2. Remember, this is the formula valid for full load. For example, if I ask you to find out at half load, you have to multiply the same formula with 0.5 factor. Okay. Anyway, and also when do we use plus sign here and when do we use minus sign? plus sign we will use for lagging power factor load, minus sign we will use it for leading power factor load. Okay, I think in the question it was very clearly given 0.8 lagging power factor. That's why we will get plus sign only, correct? Plus sign only. But the interesting thing is, what is the resistance percentage, reactance percentage? That was given in the problem already. See this? A single phase 100 kVA, 1000 volt by 100 volt 50 Hz transformer has voltage drop of 5% across its series impedance. So, percentage voltage drop is nothing but percentage impedance. Okay, it is across the impedance. So, indirectly, this 5% is percentage impedance of the transformer. Okay, so given percentage impedance is 5. Next, out of this 5% drop, 3% is due to resistance. 3% is due to resistance. Therefore, percentage R is 3. Now, the moment you know Z value and R value, can't you find out X value easily? So, what is the value of X now? Because we know X is equal to square root of Z square minus R square. And if I continue, it will be square root of what is Z square? 5 square minus 3 square. 25 minus 9. Is it not 16? Therefore, 4%. That is percentage X value. Now I have a percentage R with me and percentage X with me. I am eligible to calculate voltage regulation. So, what is percentage voltage regulation? Percentage R, that is 3%. Into cos phi 2. Cos phi 2 is the power factor. Yes, it is clearly given 0.8 lagging power factor. So cos phi 2 was 0.8. As it was lagging, we have to substitute plus sign. And we got reactance 4%. If cos phi 2 was 0.8, is it not sin phi 2 0.6? So it will be 2.4 plus 2.4. I think 4.8%. That is the percentage voltage regulation, that is option A. Okay, so this question is from voltage regulation of a transformer. But clarity is very important. Percentage voltage drop across an impedance is nothing but percentage impedance of the transformer. Is nothing but percentage impedance of the transformer. Got it? Okay, so impedance and resistance were given. We have to find out reactance first, and then we can easily find out voltage regulation of the given transformer. Okay, yes. All right. See, so far we solved almost 4 questions. All 4 are numerical type questions only. Okay. 2 questions from DC machines and 2 questions from transformers. I will go back once again. This is a numerical question. This is a numerical question. Even this is a numerical question. This is a numerical question. 4 questions we solved. All 4 are numerical type. So now see the 5th question. This is also a question from transformer subject, and it's a theoretical question. So request everybody to read the question first of all. Which of the following statement is valid for transformers? Yes, option A. In open circuit test, copper losses are obtained, while in short circuit test, core losses are obtained. In open circuit test, current is drawn at high power factor. In short circuit test, current is drawn at 0 power factor. In an open circuit test, current is drawn at low power factor. Which is the correct statement? See, the question is about OC test and SC test. The topic is OC test and SC test. Very important topic. First, we will summarize OC test and SC test. What is the purpose of OC test on a transformer? It is to measure iron loss of the transformer. Iron loss is nothing but constant loss. And we will conduct OC test always from LV side. LV side with rated voltage and rated frequency. Frequency is rated value, but current is very low, because during open circuit test, transformer will draw only no load current, and no load current is usually very, very small. Also, during OC test, LPF type wattmeter is used. LPF type wattmeter is used. Why? Because during open circuit test, power factor is very, very low. It will be usually around 0.2 to 0.3 lagging. 0.2 to 0.3 lagging. Why? Because the no load current is mainly a reactive type component. That's why power factor is very, very poor. This is about OC test. Also, we can find out shunt branch parameters. We can find out shunt branch parameters of the equivalent circuit. Transformer equivalent circuit will have shunt branch as well as series branch. The shunt branch parameters we can find out using OC test. This is about OC test. Now let's talk about SC test. What is the purpose of SC test? The purpose of SC test is to determine copper loss of the transformer. That is also known as variable loss. Okay, and SC test is always conducted from high voltage side of the transformer. Okay, with voltage a very low value, frequency rated value, current rated value. Because the purpose of short circuit test is to measure rated copper loss. Copper loss depends upon current. That's why current has to be rated value, but voltage requirement is very low. Okay. Also, during this particular test, we will use high power wattmeters. HPF type wattmeters are used because the power factor is usually more than 0.5 lagging. That's why we will use HPF type wattmeters. Okay. Also, using this test, series branch parameters can be calculated. We can determine series branch parameters of the equivalent circuit. These are the summary points regarding SC test. Okay. Now you can read the options. Look at the first option. OC test, in open circuit test, copper losses are obtained. That is a wrong statement. Correct. In open circuit test, current drawn at a high power factor. That is a wrong statement. I told you OC test means current is drawn at very low power factor. In a short circuit test, current drawn at a zero power factor. That is wrong. In a short circuit test, what is the range of power factor? 0.5 to 0.6 lagging. So therefore, third statement is wrong. In an open circuit test, current is drawn at a low power factor. Yes, that is the correct statement. The last statement is correct. In an open circuit test, current was drawn at very low power factor, 0.2 to 0.3 lagging. It's a simple question. The question is again from transformers subject. Okay, right. Another question, fourth question we have from transformers subject. Once again, it's a numerical question. Request everybody pause the video and read the question first of all. Yes, a single phase transformer has a no load loss of 64 watt as obtained from the open circuit test. When a short circuit test is performed with 90% of the rated current flowing in its both LV and HV windings, the measured loss is 81 watt. The transformer should exhibit maximum efficiency at how much percentage of rated current? See, this question is from efficiency calculations of the transformer. The topic is efficiency calculations. To answer any questions related to efficiency calculations, one should have idea about OC test and SC test. Then only you can calculate efficiency of a transformer. Anyway, read the problem again. A single phase transformer has no load loss of 64 watt. We know no load loss is nothing but iron loss of the transformer as obtained from open circuit test. When a short circuit test is performed, this is very important. Short circuit test is performed with 90% of the rated current. Okay, with 90% current, then the measured loss is 81 watt. So this 81 watt is the copper loss information, but this copper loss is at 90% of the rated current. Then what is the load at which transformer will exhibit maximum efficiency is the question. First of all, I hope most of you might have remembered. at maximum efficiency, what is the loading? X is equal to square root of iron loss divided by full load copper loss. Full load copper loss. In the given question, iron loss was very clear. 64 watt. Fine. Iron loss is 64 watt. But do we have a copper loss at full load? No. Copper loss is 81 watt, but that is not at full load, only at 90% of the current. Okay. Generally, copper loss is proportional to current or square of the current, guys. Square of the current. I gave you copper loss at 90% current. Then what will be the copper loss at 100% current? I can write down like this. Copper loss in the first case divided by copper loss in the second case is equal to current in the first case divided by current in the second case whole square. Here first case means 90% current. Second case means rated current. That means 100% current. Substitute. What is the copper loss when the current is 90%? 81 watt. 81 watt is the copper loss when the current is 90%. Then what is the copper loss in the second case? That is copper loss at 100% current is the question, is equal to current in the first case 90%, current in the second case 100% whole square. This, if you have any doubt, just to substitute percentage. Okay. Is it not 0.9 square? That is 0.81. So therefore, copper loss in the second case would be 100 watt. Now, important thing is, what is this 100 watt? This 100 watt is the copper loss at 100% current. This 81 watt is the copper loss at 90% current. Okay, so go back, substitute the data. So square root of, what is iron loss we have? 64 watt divided by, what is the copper loss at 100% current? 100 watt. So is it not 0.8? Yes. So therefore, maximum efficiency can be obtained at a loading of 0.8 per unit. Then what about percentage? 80%. So therefore, maximum efficiency can be obtained at 80% of the rated current. This is the correct answer. Most of the students, they will commit a mistake. The mistake is they will substitute iron loss is 64 watt. They will substitute copper loss is 81 watt. Directly they will substitute 64 here, 81 here. What happens? Square root of 64 is 0.8. Square root of 81 is 0.9. Then it will become 8 by 9. 8 by 9 is some value you will get that will be available in the options. Definitely it will be available in the options. But that will be a wrong answer. This is a wrong solution. Why? Because this 81 watt is not the full load copper loss. That is a copper loss at 90% current only. I need copper loss at 100% current. So that is why I separately calculated copper loss at 100% current. The rule is simple. Copper loss is proportional to square of the current. It's a simple question. So the answer is 80% of the rated current. Another numerical question, you see. All right. So that's all. We have 4 questions from transformers subject. Now the next question, this is a question from induction motor. It's a theoretical question. The torque speed curve of an induction motor is shown in the below figure. 4 points of operation are marked as W, X, Y and Z. Which one of the following represents a slip greater than 1? Who is the value representing slip greater than 1? You know that induction motor will have 3 modes of operation, right? If you take torque on y-axis and you take a slip on x-axis, it will have 3 modes of operation like this. This is known as braking mode, right? And this is the motoring mode. And this is generating mode, right? In the braking mode, what is the range of slip? Slip will be greater than 1. And in the motoring mode, this is the starting point where slip equal to 1. This is the synchronous speed point where slip is 0. So in the motoring, the range of slip will be 0 to 1. And if it is a generator, slip will be less than 0. Negative slip will come, less than 0. Now what the question they are asking, what is the region represents a slip greater than 1? Slip greater than 1 means, is it not braking mode? Braking mode means according to the curve, is it not W point? Yes. So therefore, operating point W, this represents a slip greater than 1. For example, if I ask you which point represents a slip less than 0, that is negative slip, then Z is the answer. Okay. Which represents a slip between 0 to 1 in the motoring mode, X and Y. They are between 0 to 1. Clear? Anybody who has idea about torque speed characteristics of a three-phase induction motor, they can easily recognize this particular question. Easy question. Okay. We have one more question from induction motor. No load test on a three-phase induction motor was conducted at different supply voltages, and a plot of input power versus voltage was drawn. This curve was extrapolated to intersect the y-axis. What is the intersection point yields? Is the question. Okay. So this is a quite interesting question. Okay. Pause the video, read the question again, understand what is the data given. So I think I forgot to mention the previous question is from which topic. This is a topic known as torque speed characteristics of three-phase induction motor. A very simple topic. Okay. Now this question, it is no load test and blocked rotor test question. Just like open circuit test and short circuit test, in induction motor we have no load test and blocked rotor test. The question is from that particular test. Okay. Anyway, if you read the question carefully, it is very clearly given no load test on a three-phase induction motor was conducted at different supply voltages, and a plot of power versus voltage was drawn, and it was like extrapolated curve. That means it was like this. You take voltage on x-axis, you take the no load power on y-axis, and it will be like a extrapolated curve intersecting y-axis at a particular point. Those who studied no load test and blocked rotor test, you must recognize this curve. This is a curve and this is a test we will conduct to separate constant losses of induction motor. You know, the purpose of no load test is to determine constant losses. To determine constant losses, right? And in induction motor, constant losses are two types. Okay. Yes, I can write constant loss is equal to, it is the combination of iron loss and mechanical loss, also known as friction loss. Iron loss and friction loss. Out of these two, the value of iron loss depends upon voltage and frequency, whereas friction loss will only depend upon speed of the machine. And during no load condition, the speed will slowly depend upon frequency only. Now in the question they said very clearly, input power versus voltage was drawn and the test was conducted at different supply voltages. Okay. That means voltage is a variable quantity. No information about frequency. That means frequency is constant. So we don't change frequency. That's why friction loss doesn't change. Am I right? Only this iron loss is going to change because we are changing the voltage. And this intersection point will represent the magnitude of the friction loss. This is going to represent the magnitude of the friction loss. And this variable curve, this variation is nothing but iron loss variation. Why iron loss is varying? Because we are changing the voltage in the test. They said very clearly, the test was conducted at different supply voltages. Different supply voltages. That's why iron loss is variable. No change in friction loss. That will be the intersection point. So the intersection point will tell you friction and windage losses. Yes, this is option D. All right. What is that? Variable curve is representing the iron loss. Okay. So this is separation of constant losses in induction motor. Clear? Okay. So the next question we have, this is a question from alternators, that is synchronous machines. Read the problem. A field excitation of 20 ampere in a certain alternator results in an armature current of 400 ampere in short circuit and a terminal voltage of 2000 volt on open circuit. The magnitude of internal voltage drop within the machine at a load current of 200 ampere is how much? That is the question. See, the question is from yes, OCC and SCC curves. This is OCC and SCC characteristics topic. Okay, many characteristics we use to draw for synchronous machines, open circuit characteristics and short circuit characteristics. With the help of open circuit characteristics and short circuit characteristics, we can find out what? The synchronous impedance of the alternator. What is the formula for synchronous impedance? Synchronous impedance is written as open circuit voltage divided by short circuit current, but both must be measured at same field current. Same field current. That means if I measure open circuit voltage at a field current of how much is given? 20 ampere, field excitation of 20 ampere. Short circuit current should also be measured at same field current. First of all, is it a three-phase machine or single-phase machine? Nowhere it is written, right? Nowhere it is mentioned three-phase or single-phase. Therefore, it is single-phase only. If it is a three-phase, it must be specifically mentioned, like three-phase star connection, three-phase delta connection, or something like three-phase. Some information must be there. Nothing is given. That's why I will assume it as single-phase only. Field current was 20 ampere. At that field current, short circuit current was 400 ampere. Open circuit terminal voltage was 200 volt. Okay, both are measured at same field current. So therefore, open circuit voltage was 2000 volt. Short circuit current was 400 ampere. I am directly substituting these values because the machine is single phase. For example, if the machine was a three phase, this 2000 would have been a line voltage. Then the phase voltage would have been 2000 by root 3. Okay. Next, short circuit current 400 ampere will be a line current. Then phase current will also be 400 only, because usually it will be star connected. Okay, but here you need not worry. I think it will be 5 ohm, right? Two zeros will cancel. 20 by 4 is 5. So I got synchronous impedance 5. But what is the answer I need? What is the magnitude of internal voltage drop within the machine at a load current of 200 ampere? Generally, if you draw the circuit diagram of a machine, this is the induced EMF of an alternator. In series with that, we have a synchronous impedance. And then we have terminal voltage here, okay, across the load. Therefore, what will happen? Normally, when armature current flows through this machine, due to this armature current and synchronous impedance, definitely some voltage will drop across this impedance. That's the question they are asking. What is the voltage drop across this impedance internally to the machine because of this load current? How much is the load current? 200 ampere. Is it not simply IA into ZS? Therefore, the voltage drop is equal to IA into ZS. IA was 200 ampere. What is the ZS value? We got 5. So, is it not 1000 volt? So, the voltage drop internally to the machine was 1000 volt approximately. This is not exact value. Why? Because this ZS is a combination of RA and XS. Both drops we have to vectorially add, but here we are doing it approximately. So approximately the voltage drop would be 1000 watt, 1000 volt. Understand? Okay. So that is the answer. Simple. Okay. So this question is from open circuit test and short circuit test of a synchronous generator. Okay, next we have another question from salient pole synchronous machine. Yes, the question is from two reaction theory. This is two reaction theory topic. In a salient pole synchronous motor, the developed reluctance torque attains maximum value when the load angle in electrical degrees is approximately how much? See, those who studied two reaction theory topic, you know, the power developed by salient pole machine, it will have two components in it. One is electromagnetic component, another one is reluctance component. If I write down, it will be EF into VT by XD into sine delta plus Vt square by 2 into 1 by XQ minus 1 by XD into sine 2 delta per unit. Okay, so this is the actual power flow equation in salient pole synchronous machine. So in this power equation, the first component, this EF into VT by XD into sine delta, we call it as electromagnetic power component. Okay, whereas the second one, this is known as reluctance power component. Okay. Now the question is, at what load angle maximum value of reluctance torque will be maximum at what load angle? Can I say reluctance torque will depend upon reluctance power? If reluctance power is maximum, then only reluctance torque will be maximum. And if you carefully understand, reluctance power is proportional to sine delta or sine 2 delta. Can I say sine 2 delta will be maximum when delta is equal to 45 degrees? Yes. If delta is 45 degrees, then sine 2 delta will be maximum. That means reluctance power will be maximum. If reluctance power is maximum, indirectly reluctance torque will also be a maximum value. Okay. So the answer is 45 degrees. 45 degrees is the answer. That is the load angle at which reluctance torque will be maximum. Okay. Clear? Okay. See, we have one more question from synchronous machine. This is a question from synchronous motor. If a synchronous motor is running at a leading power factor, its excitation induced EMF EF will be. Remember, this question is from types of excitations. Types of excitations. In synchronous machines, there are three types of field excitations: over excitation, under excitation, normal excitation. So the first point everybody has to understand, the question is a motor, synchronous motor, and it is running at leading power factor. Remember, synchronous motor at leading power factor. Okay, this means it is overexcited. If it is lagging power factor, underexcited. What is mean by overexcitation? Overexcitation means EF cos delta is greater than terminal voltage. You take cos delta to the right side. EF is greater than 1 by cos delta into VT. Cos of any angle except 0 degrees. What is cos 0? 1. But cos of any other angle will be less than 1 only. Then it will be 1 by less than 1. 1 by less than 1 is nothing but greater than 1. Then EF will be greater than 1 into VT. That means overall can I write EF is greater than VT. Therefore, an overexcited machine is nothing but induced EMF magnitude will be more than terminal voltage. So the answer is induced voltage EF is higher than the terminal voltage. That means option C is correct. Higher than terminal voltage. Correct. Okay. Yes. Fine. So we have one more question. This is also from synchronous machines only. So you can read the problem. A three-phase synchronous motor drawing 200 ampere from the line at unity power factor and at rated load. Considering the same line voltage and load, the line current at a power factor of 0.8 leading is how much? First of all, it is a 3-phase synchronous motor drawing 200 ampere from the line at unity power factor and at rated load. Considering the same voltage and the same load, what is the new current at a power factor of 0.8 leading? First important information. Initially, the motor was drawing 200 ampere at unity power factor, okay, at rated load. This is the first case. In the next case, considering the same line voltage, this is the first important information, and the same load, this is the second important information. What is the new current? What is the new current at a new power factor of 0.8 leading? They said very clearly, same voltage, same load. When I say same load, in the sense, same active power. Load is nothing but, for a motor, can I say load is nothing but mechanical load only? Mechanical load indicates active power. So when I say same load, indirectly, active power is constant. What is the formula for active power? Active power is equal to root 3 VL IL cos phi. So in this they said active power is constant. Same line voltage. Voltage is also constant. Therefore, can I say current is inversely proportional to power factor? If current is inversely proportional to power factor, are you understanding? You just take cos phi to the left side, current and power factor are inversely proportional. So first case current divided by second case current is equal to second case power factor by first case power factor. What is the first case current? Yes, 200 ampere. 200 ampere divided by the new current we have to find is equal to, what is the new power factor? 0.5 previous power factor unity. So from this you will get the new current, which is 400 ampere. Okay, so this is a question from a simple equivalent circuit of a synchronous motor. Simple question. They said very clearly same load. Remember, load means it's active power. Why? Because it's a motor. When I say it's a motor, for a motor, load is mechanical load. Mechanical power is always active power, guys. Please remember that. Mechanical power is always active power only. Mechanical power is always active power. So when I say same load, indirectly same active power. Clear? So the new current was 400 ampere. That is the last option is correct answer. 400 ampere is the correct answer. All right. Okay. That's all. That's it, guys. So these are the questions from electrical machines subject in AP TRANSCO 2019 paper. I must say most of the questions are numerical type. See, this is a numerical question. This is a theoretical question. This is a theoretical or numerical, you must say. It's a numerical type only because we need to find the angle. This is another numerical question. This is a theoretical question. This is a theoretical question. This is another numerical question. Okay, a theoretical question, numerical question, numerical question, numerical question, numerical question. See, majority of the questions are numerical type. Out of the 12 questions, 8 questions are numerical type, 4 questions are theoretical type. So most of the times at AE and AEE level papers, 60 to 70% of the paper will have numericals, especially core subjects. You can see in this particular subject itself, you found majority of the questions are numerical type questions. So you have to practice numerical problems very carefully. Okay. So that's it. This is from electrical machines side.
Hello everyone. Welcome to the discussion on AP TRANSCO 2019 paper. So here we'll start with digital electronics first, and then we'll move on to microprocessors. Okay, so let's read this question. The present output of an edge-triggered JK flip-flop is 0. So whatever is this 0 that you see here, so this is basically the initial state. Okay, so the state that you see here is basically the so-called initial state. right? And then we have j is equal to 1. No information about k is given to you, but that's okay. So we have to solve this question without the k information. So don't think that, okay, maybe the problem has some insufficient data and stop the problem. Write the characteristic equation of your jk flip-flop. What is the characteristic equation of jk flip-flop? qt plus 1 is given by j q bar plus k bar q. K bar q. Okay. So where here q corresponds to the present state qt or qn. Anything is okay. And substitute the values now. What is this j? J is equal to 1. 1 into, what is the value of q? Q initial state is 0 bar plus I don't have the information of k bar into q is equal to 0. So the second term is entirely gone. So irrespective of your k value, the k value does not affect your final answer. Okay. So this becomes equal to now 0 bar is 1. 1 into 1 is 1. 1 plus 0 and final answer is equal to 1. So means the next state becomes equal to 1 irrespective of the k value. Okay. So finally, what is the answer now? The answer is nothing but D. Some people may go for indeterminate assuming that k information is not given. Okay. So don't think it like that. So next we have, the minimum number of 2-1 multiplexers required to realize 8-1 mux. Okay. This is something that we very commonly discuss in the class also. The same kind of a procedure is something that we have even for the case of decoders. Okay, in the sense that implement, let's assume 416 decoder or 38 decoder by using, let's assume 12 decoders or 24 decoders, etc. So there also the procedure remains same. Okay, what is the procedure? This is the bigger sized decoder. Let me call this as N1 and this value as nothing but N2, right? And then you take the value of N1 by N2. You get some ratio, that number is nothing but 4 because we are taking here 8 by 2. 8 by 2 becomes equal to 4. Repeat the process with the new quotient here. So which is 4 divided by, okay, the 4 that you have obtained here divided by always N2 in the denominator. 4 by 2 becomes equal to 2 and lastly 2 by 2 becomes equal to 1. So when you get either 1 or 0 point something, you are supposed to stop the process. And now add all these coefficients that you obtain on the RHS. 4 plus 2 plus 1. 4 plus 2 plus 1 is 7. So the meaning of this 7 is nothing but 7 smaller sized multiplexers are required. 7 2-1 muxes are needed basically. For the bigger mux, which is 8-1 mux. Okay, so that is the meaning of this particular, number 7. Right? So this is the process to solve this kind of a question. Let's go for the next one. Yeah, so we got only one question from microprocessor, and that's why it's a a programming based question. It's basically instruction based. I shouldn't even say programming, but rather it's simply based on instruction. Okay, so we have the contents of the register B given to us. There is register B information specified, and then there is also a register or the accumulator information specified to us. We have the accumulator information, register B information. So what is the value of register B? The B information is given as, this is how much, 49 in hexadecimal format, and then the contents of the accumulator is given as A is equal to 3A in hexadecimal format. Okay. So after that, we are supposed to find out the contents of the A accumulator register and then the status of the carry flag as well as also the sign flag. Okay. So after executing the instruction, which is nothing but sub B. So what does this instruction do first? Okay. Whenever you have this instruction sub B, so you are supposed to subtract. So subtract what from what and put that result where? So we are doing the subtraction of A minus B, and the contents of A minus B are being inserted in A again. Okay, so this is the operation that is happening. We are performing the operation A minus B. Current A value minus current B value. Whatever result you obtain will be the new value of A. Okay, so there are two ways of approaching this problem. One approach is nothing but you can directly do the subtraction process, but that's quite lengthy. Or you can also go for A plus minus B, that is take B in terms of 2's complement format, do the calculation. That is also one more approach. Now we will go for those approaches whenever the flags are other than what are given here. Maybe if the question is about auxiliary flag, please find out the state of auxiliary flag, auxiliary carry flag in fact. So we don't have a choice except to go for the complete subtraction or addition process. But here all I'm supposed to do is nothing but find out what is the state of carry flag and then what is the state of sign flag. Okay, so how does carry flag be affected? So carry flag becomes 1, okay, when carry is taken at MSB stage. Okay, this is for addition. What if you are doing subtraction? The same thing is repeated, replaced with borrow. Okay, so carry flag becomes equal to 1 when borrow is taken at MSB stage. And this happens when? So the borrow at the MSB stage is taken whenever A is less than B. We know that borrow is taken whenever A is less than B. When A is greater than B, there is no necessity of borrow. Only when A is less than B, we have to take a borrow at the MSB stage. So all I'm supposed to do is now compare the numbers AB and decide whether carry flag becomes equal to 1 or not. This is for the first case. Again, sign flag. We all know again, sign flag becomes 1 when? Okay, sign flag becomes 1. At least in this case, when the result of the arithmetic operation is basically a negative number. Okay, when the result is negative. So it means that when A is less than B again. So when A is less than B, sign flag becomes 1, carry flag becomes 1, at least in this operation, in the subtraction operation. And sign flag becomes 0 and carry flag becomes 0 when A is greater than B. Okay, so if you have this much amount of understanding, then we can proceed further. So for this problem, all I have to do is nothing but, I have to do the calculation, that is A minus B, which we will definitely do. But apart from that, if you convert them into values, the problem becomes much more easier for you, right? So let's convert them into values now. Okay, what is the value of 49H? And what is the value of 3AH? Yeah, since hexadecimal base value is 16, 4 into 16 plus 9. So in terms of decimal, this is 64 plus 9. 64 plus 9 is 73. And 3AH, this is 3 into 16 plus A. What is the value of A? The value of A is equal to 10. Okay, so 10, which becomes equal to 16 into 3, 16, 48 plus 10, 58. Okay, 58. So this is what we have. And on the basis of these two, if I verify which is larger, A is 58 in decimal and B is 73 in decimal. So I can clearly see that A is basically less than B. So since A is less than B here, I can for sure say that my carry flag is set to 1. So due to this reason, I would surely say that carry flag is set to 1. And because you have to take a borrow at the MSB stage, and then sign flag is set to 1 because the result is a negative number. Okay, so since the result will be a negative number, I don't know even the value. I don't even care, at least for the time being. I would definitely say that CY and S, carry as plus sign flag, becomes equal to 1, which happens in option A as plus also option B. Now again, I have to decide what is the exact value of the number. One thing I can surely say again here also is the number has to be negative number. So if the number is negative number, what is the MSB bit that you will get? MSB is not 0. So if MSB is 0, it means that result is positive. Okay, can the result be positive? No. So the answer is not B, the answer is A. So the answer, that is the contents of the accumulator after the operation, has to be equal to F1. Let's verify. When you take the subtraction here, which is A minus B, okay, We'll do the subtraction here though. Okay. I'm doing now A minus B. I'm doing the subtraction in decimal since I already have having the decimal numbers here, which is 58 minus 73. So what is 58 minus 73? 58 minus 73 becomes equal to minus 15. Okay. So convert this minus 15 in terms of 2's complement format. That's the standard complement format for negative numbers. So yeah, sign bit becomes equal to 1 here. And what about your magnitude bits? Magnitude bits are 1, 1, 1, 1. Then take complement. If you take complement for 1, 1, 1, 1, you get 4 zeros. And then if you add a 1 to it, you get all zeros 1. Okay, you get all zeros 1. And yeah, so finally what do we have? We have the result of A minus B. Okay, we have the result of A minus B being equal to, anyway, this is the lowermost nibble. So this lowermost nibble becomes equal to the lowermost nibble becomes equal to 1. This is, and what about your sign bit? Sign bit becomes 1, which has to be copy pasted 4 times because of sign bit extension. Ultimately, minus 15 has actually been a 5-bit number. You are supposed to write it as 8-bit number. In 8-bit number format, this becomes equal to all ones. So all I've done is nothing but sign bit extension here, which corresponds to, F. 4 ones in hexadecimal format is F. So finally, what is the answer we have? The answer is F1. This is for cross verification only. We already got the answer, that the answer is nothing but F1. Now all we are doing is nothing but we are simply cross verifying, right? So this is regarding this question. Okay, so let's now look at questions on measurement subject. The first question we have is, it's a question on 2 wattmeter method. So a 3-phase balanced load has a power factor of 0.707. So power factor is given to us. So from this power factor angle also we can calculate. So we have been given cos phi. So cos phi is equal to 0.707. Then what is the value of phi? Phi becomes equal to cos inverse of 0.707, which becomes equal to 45 degrees. It's basically 1 by root 2. Cos inverse of 1 by root 2 is 45 degrees. Lagging, leading information we don't have. Okay, so whether it is lagging or leading, that information we don't have. Now this is connected to a balanced supply. The power consumed by the load is 5 kilowatt. So we have the information of total power consumed right now, which is nothing but 5 kilowatt. Right? So this information we have. So yeah, so we have power delivered to the load, which is PL, and that PL becomes equal to 5 kilowatt. So in 3-phase systems, what is the formula for power also equal to? This is root 3 VL IL times cos phi. Okay. Yeah, here we have the information of cos phi. I don't have the information of VL IL. Okay. Okay. So apart from that, okay, given this data, now you are supposed to find out the individual power in each of the wattmeters. Okay. So what is the reading of each wattmeter in case of the 2 wattmeter method? So wattmeter 1 reading is equal to, this is VL IL times cos 1 is 30 minus phi, 30 degrees minus phi. And the second wattmeter reading is VL IL cos of 30 plus phi. While doing the derivation, we will get these numbers. And when you add W1 plus W2, we get the total power, which is nothing but root 3 VL IL cos phi. So now we are supposed to find out these individual values of W1 as well as W2. To calculate this, I require VL IL product. Do I have phi? Yes, I do have phi. And how much is this value? This becomes equal to VL IL times cos 30 minus 45. Okay, cos 30 minus 45. I'm reading the answer directly here, which is cos minus 15. All I'm doing is substituting this value of phi. And how much is this value of phi now? Phi is equal to 45 degrees. And if you do that substitution, you get this as basically cos minus 15 in the first case. What is cos minus 15? Cos minus 15 is also equal to cos 15. So this becomes equal to cos 15. Whereas this becomes equal to VLIL cos 30 plus 45. It is 75 degrees. Okay. Okay. Now let's calculate what is the value of VLIL. For that I'm substituting this value of cos phi. What is the value of cos phi here? The value of cos phi is root 2. And from this, the value of VLIL. Okay, VLIL value becomes how much? This is 5 into root 2 by 3. Okay, so 5 into root 2 by 3. Okay, if you substitute those values here, then we get the value of W1. W1 to be equal to how much? 5 root 2 by 3 into cos 15, and W2 becomes equal to 5 root 2 by 3 cos 75. Okay, now we all know that whenever the angle is very close to 0, then in that case the cos of that particular angle becomes almost equal to 1. Okay, this value, if you see, so this value will be very close to 1. Yeah, it is definitely less than 1, but rather very close to 1. So this is a number which is close to 1. Whereas when the angle is very close to 90 degrees, in that case, that particular cos of that particular angle becomes very close to 0. So hence this becomes very close to 0. So I mean to say that one of the wattmeter reading is having a value which is very close to 0, and the other one which is very close to the full scale value, which is nothing but 5. Okay. So this is what we are supposed to do. We are supposed to verify options. Okay. We don't have any other way of solving this question. If you have calculator, you can very well do it, but rather in the exam, AP TRANSCO exam, we don't have a calculator. So because of that, we are supposed to go with options. Okay. Option B, is it a correct one? No, because definitely I can clearly see that W1 is not equal to W2. So here in this case, W1 has been given same as W2. They cannot be same, so this is gone. And even option C is wrong, because here it says that one of the wattmeter reading is 0. Okay, one of the wattmeter reading is 0. Maybe W2 is 0, it says. Is it true? No, because the value of W2 is very close to 0, but still greater than 0, not equal to 0. So because which option C is wrong. And if you see here, here W1 and W2 values are comparable. They are not equal, but rather they are comparable. I would say here W1 is comparable to W2, which will not occur. Okay, they are W1 is greater than W2, but rather the difference between both of them is not so great, not large. So this cannot happen. But if you see here, yeah, one number, one of the wattmeter reading is closer to 5, the full scale reading, the total power reading, and the other guy is close to 0. Okay, not equal to 0, but rather it is close to 0. Then yes, the most appropriate answer in the current scenario is nothing but A. And if you want to cross verify, you can do the substitution. You can use calculator at least before the exam right now in order to cross verify whether these answers are correct or not. Okay, and if you substitute these numbers in the calculator, you will end up getting the first answer as nothing but 3.94 and the second answer as nothing but 1.06. Okay, yeah. So this is regarding this question. Next, which bridge is best suited for harmonic distortion analyzer? So what is this harmonic distortion analyzer doing? First of all, this is measuring the harmonic content in the given input signal. Okay, that is how much amount of harmonic content we are having at every frequency. That's what we are verifying here, starting with the fundamental frequency. So since we will be knowing the information of fundamental frequency, I know what are the harmonics I'm supposed to verify. Okay, so it simply measures the harmonic content in a signal, and we compare that particular harmonic content with respect to the fundamental content. So here there is some kind of a frequency measurement. The signal or the device has to be very much frequency selective. So due to this reason, whatever measuring instrument we are using here, the measuring instrument has to be frequency selective. Okay, so this guy ultimately has to be frequency selective. Right? And the instrument that is given to us, amongst all the instruments that is given to us, the instrument which is highly frequency selective is nothing but Wien bridge oscillator, which also measures the frequency. Okay, the Wien bridge oscillator, it also measures the frequency of your unknown frequency values. Apart from that, it can also act as a bridge in such a way it is highly frequency selective. Whereas if you see the other option, sharing bridge measures what? This guy measures capacitance. So sharing bridge is used for capacitive measurements. Whereas Kelvin double bridge is used for very low resistance measurements. Whereas heap side bridge is used for inductance measurements. No, I mean to say this is also one method of eliminating the options. So inductance measurements, not measuring any frequency. Kelvin double bridge making low resistance measurements, not measuring any frequency. Sharing bridge measures capacitance, but it does not measure any frequency. So again, due to all these reasons, we can say that A, B, and D are wrong. The only correct answer is nothing but C, Wien bridge oscillator. Okay. Yeah. Next. Yeah, we are supposed to find out a wrong statement with respect to potentiometer. Okay, so please highlight this always because this is where people generally do mistakes. They read incorrect as correct and correct as incorrect. That's one mistake people do. And with respect to what potentiometers, okay, so let's go with the second option. They are basically null type instruments. Correct? Yes, this is definitely a correct statement. Statement is pakka correct. Okay. How is the circuit for a potentiometer looking like? We may have some variable resistor connected to a known voltage source. We may have a known voltage source here. Okay, so this is known voltage which is connected across a long rail of resistance. Let's assume. And then whichever is your unknown value, then you have a galvanometer. And connected to the galvanometer is your unknown voltage. And this unknown voltage lead here is being drawn on this particular rail. So this is voltage unknown. And when do we stop this? We stop this whenever galvanometer shows null reading. We all know that galvanometers are very sensitive to the current. Okay, they are very sensitive current measuring devices. So whenever the current flowing through that is 0, then the reading is also equal to 0. When the current is even a very, very small value, then the reading is a non-zero value. So when we are stopping this whenever the galvanometer reading shows 0. And because the galvanometer reading shows 0, we stop the process. We call this as nothing but null type instruments. Okay. And standardization of DC potentiometers is done using DC standard sources. Pretty much correct. Okay. What are the DC standard sources we may use? We may use the standard cell. Okay. The standard Western cell. Having nearly the standard voltage of 1.0158 at 20 degrees centigrade. So this is something that we can use in order to calibrate the DC potentiometer. Okay. And standardization of AC potentiometers is done using the AC standard sources. There is no AC standard source. We have to note that we do have DC standard sources in the form of standard cells, but rather we don't have anything called as AC standard sources. Okay, so please note that nothing of this sort is available. So there is nothing called as AC standard sources. So yeah, this option D that you see is a wrong statement and hence correct answer. Okay. Yeah, this can be used for AC magnetic testing. Yes, this is also used for AC magnetic testing, mainly for measuring the self-reluctance of a coil. Okay. So where do we use this? In order to measure the self-reactance of a coil. Okay, so in measuring the self-reactances of the coil, we again use potentiometers. Okay, but yeah, there is nothing called AC standard sources. So how do you standardize even AC potentiometers? By using a DC source. Okay, so even here, the standardization of AC potentiometers is done by using DC sources. Okay, yeah. So this is what we have regarding this question. Next. A moving coil galvanometer is made to a DC ammeter by connecting dash. Okay, so we want to convert a galvanometer into a ammeter. So that's the goal here. For that, we have to know the property of a galvanometer. Galvanometer, even like in the previous problem we have discussed, this is a very current sensitive device. Okay, so this is a current sensitive device. In the sense that the range of this particular galvanometer will be of the order a few milliamperes. Means the full scale reading of this galvanometer will be of the order a few milliamperes. Okay. So as such, if you don't do any connections for this particular galvanometer, then the current range, how much is the current range here? The current range is of the order a few milliamperes. So very low value of your current. Now I want to expand the range of this particular so-called ammeter. This is basically ammeter. Now I want to expand the range of this particular ammeter. We all know that how do we expand the range of ammeter? By connecting a resistor in series. By connecting a resistor in shunt configuration. So if this is our galvanometer now we are discussing about the range extension. Okay, so this is our galvanometer having certain current rating. Okay, having certain current rating. Now I want to expand the current range of this particular galvanometer, for which I'm connecting a shunt branch. So this is basically RSH, and this entire block right now can function as what? An ammeter. Now let's assume the full scale reading of this galvanometer is nothing but Ig, that is the maximum current that can be handled by this particular, the full scale reading or rating of this particular galvanometer is Ig, and we want the full scale reading to be a larger value I, maybe of the order of few amperes, maybe of the order of few tens of amperes, let's assume. So for that, what is the value of RSH you are supposed to connect? So we have one formula. Okay, RSH becomes equal to Rg, which is the resistance of galvanometer, divided by scaling factor minus 1. Okay, so here, what is this scaling factor now? This scaling factor becomes equal to, wherein here m becomes equal to the new value of current that you want to measure by Ig. Ig, like we have discussed just now, will be of the order of few, milliamperes. This is a few milliamperes. Even if you want I to be of the order of few amperes. So then what is the value of your m? The value of m is large. Okay, we can see the value of m is basically a very large value. of the order a few hundreds or thousands basically. So if let's assume m is of the order of few hundreds or thousands, then what about the denominator here? Denominator will be a large value because of that. If denominator value is large, what about your shunt resistance value? It will be very small. So that's it. So it answers both of our questions. Where are we connecting the resistor? We are connecting the resistor in shunt configuration, means across the meter, not in series with the meter, but rather across the meter. So option C and D are wrong. C is gone, D is gone. Now, should that resistance which is being connected across the meter means shunt configuration, should that resistance be a large value or small value? It should not be a large value. Just now we have shown that, yeah, scaling factor has to be large, and for that purpose the resistance value has to be really small. So hence the resistance value has to be a very small value. Okay. 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 So in this question we have a energy meter question. It's a one phase 240 volt induction type energy meter. And how much is the voltage given to us? 240 volt. And the meter constant is given as 600 revolutions per minute. So it means that 600 revolutions per kilowatt hour. So 1 kilowatt hour corresponds to how many revolutions? 600 revolutions. And for a load current and certain power factor given to us, we want to calculate how many rotations the disk does for every 1 minute. So here this is rotations per minute, and hence how much is the time frame given to us? 1 minute, which can be expressed in hours as what? 1 by 60 hours. Okay. Yeah. So let's calculate the energy first of all consumed in 1 minute. Okay. So energy consumed in 1 minute. See, all I'm supposed to do is nothing but I'm supposed to calculate this energy in terms of kilowatt hour, so that I can directly use this particular formula. Okay, so what is the formula for energy? That is nothing but power into time. And how much is the value of power? Active power, VI cos phi. VI cos phi into time. What is time? 1 by 60. 1 by 60 in terms of hours. See, I want the answer in terms of kilo. So because of that, power is being divided with 1000, because ultimately the answer has to be in terms of kilo. VI, none of them are in terms of kilo, so ultimately I want the answer in terms of kilo, hence I'm taking this particular 1 by 1000. Now do the calculation. This is 240 into current is 10 into power factor is 0.8, lagging, leading, not our headache, by 1000 into 1 by 60. So when you do the calculation, 60 cancels out 244 times, right? And overall this becomes equal to, I think this is 32, numerator is 40, 40 into 0.8 is 32, 32 by 1000. So this is the answer in terms of kilowatt hour. Okay, so now I have the required data. The amount of power that is consumed or energy that is consumed is how much? The energy is equal to 32 by, this is 32 by 1000 kilowatt hour. If this much amount of kilowatts we have, units we have, then how many revolutions the disk will do? Aptitude logic right now, this is 600 into 32 by 1000 divided by 1, this many number of rotations. So let's do the cancellation. Yes, gone. 32 into 6. Okay, so how much is 32 into 6? 12, 192. 192. So this overall becomes 192 by 10, which is 19.2. 19.2 RPM. Okay, so this is the disk speed whenever the voltage is 240, current is 10, and power factor is 0.8 with a meter constant of 600 revolutions per minute. Yeah, the answer is nothing but 19.2 in this question. Right.
Okay, now we will discuss the questions related to power system subject, along with utilization of electrical energy and three-phase circuits. So let's see the first question. The geometric mean radius of the conductor configuration is asking. Here is clearly mentioned the radius of each conductor is what? R. Okay. So if you notice here, there are three conductors and they are forming an equilateral triangle. Yes or not? They're just forming an equilateral triangle. The centers are forming an equilateral triangle of side equal to what? To R. From here to here R, here to here R. 1, 2, 3, 3 conductors. Since we have 3 conductors now, we can write 9th root of 9 terms. What are those 9 terms? D11, D12, D13, D22, D21, D23, D33, D31, D32. But if you write the terms with respect to conductor 1, with respect to conductor 2, with respect to conductor 3, you are going to get the same. So what I am trying to say, there are 2 ways to solve. 9th root, writing all the terms, D11, D12, D13, D22, D21, D23, D33, D31, D33, sorry, D32, okay, fine. These are the 9 terms, right? Instead of writing like this, otherwise, cube root of what? D11, D12, D13. If you write like this, you are going to get what? Same answer. The reason is, there exists a symmetry here between the terms. D11, D22, D33 are same. D12, D21, D31, D13, D23, D33. All these are what? Same. That value is what? 2R. That's why I'm saying it is going to be same. So both the way you get the same answer, but I'm writing using this cube root of what? D11 means what? E power minus 1 by 4 times R. D12, 2R. D12, D13 also 2R. Cube root of e power minus 0.25 R, 2R, 2R. What is the option which is matching that? So only option A. So the answer is what? A. Now we'll move on to the next question. The conductors of 1.6 kilometer long 3-phase 3.3 kV overhead lines are horizontal formation with 762 mm between the centers. See, it has to mention like this. Instead of mentioning between the centers, between the adjacent conductor centers, because since it is an horizontal spacing, right? Let's say center to center distance between adjacent conductors is what given here indirectly. This is D, this is D. Now in that case, this is what? 2D. Now what is the question actually? The equivalent spacing means what? Is asking to calculate what is GMD. For this case, what is the GMD formula? We know 2 power 1 by 3 times D. So 2 power 1 by 3 into what? D. D is what? 762. So 2 power 1 by 3 is approximately 1.259. Okay. Right? Even I will check in calculator. 2 power 1 by 3. $1.259 into what? 760. If we solve this, which is approximately 960 mm, because the given is in mm. So the answer is what? 960. Okay, clear? Now the next question. A 3-phase transmission line with sending and voltage given 400 kV. So and also ABCD parameters given. What is the value of inductive shunt reactor required for compensating Ferranti effect? The meaning of what? Compensating Ferranti effect is no Ferranti effect. No Ferranti effect means what? VR dash equal to Vs. But as for the given parameters, VR dash equal to what? Vs by A. A is 0.8. So we get what? VR dash equal to 1.25 times Vs. Yes, that is called Ferranti effect. Now to reduce the Ferranti effect, definitely we have to connect a shunt inductor at the receiving end of the transmission line. Let's say this is the transmission line represented with ABCD parameters. At the receiving end side, I connected an inductor whose impedance is what? JXL external. Whose admittance? Admittance means 1 by JXL external. Now he's asking what is the value of XL external. So after connecting this branch, now you need to calculate the new ABCD parameters. The A dash is the new A dash after connecting this should be equal to 1. So because we want VR dash equal to Vs. VR dash equal to Vs means no Ferranti effect. That is what the meaning of compensating Ferranti effect. Compensating Ferranti effect means what? we must ensure that there should not be any Ferranti effect. We must ensure that there should not be any Ferranti effect. So to do so, so VR dash equal to Vs and A dash must be equal to 1. A dash must be equal to 1. What is A dash? A dash, B dash, C dash, D dash equal to what? A, B, C, D. These two networks are cascaded, right? If the networks are cascaded, then ABCD parameters are matrix multiplied. What is the ABCD parameters of this? 1, 0, Y1. Okay, Y means Y external. So now tell me, we want to calculate only A dash. What is A dash? A plus B into Y external. A is what? A dash 1. A is what? 0.8. B, Y external means, B is what? 100 at an angle 90 means J 100. 1 by J XL external, right? So now tell me, JJ get cancelled. What is XL external? So 100 by 0.2. 1 minus 0.8, 0.2. 100 by 0.2 is the answer. So which is nothing but what? 500 ohms. So the answer is 500 ohms. Now let's see this question. A large power system is represented with E Thevenin and Z Thevenin. Okay. The large power system is represented with what? E Thevenin and Z Thevenin. Now, a capacitor is connected at that bus bar to maintain the bus voltage to 1 per unit. That means after connecting a capacitor, what is the voltage here? 1 per unit. 1 at an angle 0. All are given in per unit. The voltage here is what? E Thevenin given 0.9 at an angle 0 degrees. Z Thevenin given what? 0.25 at an angle 90. Now tell me, what is the MVR rating of this capacitor? So MVR rating of this capacitor means what? First of all, what is the reactive power generated by this capacitor? We need to calculate. You can calculate the reactive power generated either V square by XC. V is, reactance you calculate. Otherwise what? Vi sin phi. Both the way you get the same answer. But we need I, whatever you want to do. Okay. How to calculate I now? Using simple circuit logic. This voltage minus this voltage minus this voltage by total impedance. Tell me, 0.9 at an angle 0 means 0.9. 1 at an angle 0 means 1. Divide with what? The impedance is 0.25 at an angle 90. So what I get now? Minus 0.4 at an angle minus 90. So we can also write this is 0.4 at an angle plus 90. So tell me, what is the reactive power? Vi sin phi. The angle between voltage and current is 90 degrees. Voltage is 1, current is 0.4 magnitude. Sin 90 means what? 1. So we get what? 0.4 per unit. So tell me, what is Q actual? Is nothing but what? Per unit value into base value. Base value given 100. 0.4 into 100, which is nothing but what? 40 MVAR. The answer is 40 MVAR. So we calculated Vi sin phi. How we calculated I? Using circuit logic. The angle between voltage angle is 0, current angle is 90. The angle between voltage and current is 90 degrees. Okay. So simple question. The next question. A transmission line has equal voltage at two ends. A third source is provided to maintain the constant voltage equal to the end voltage at either the midpoint or 75% of the distance from sending end. The maximum power transfer capabilities of the line in the original case and case 1 and case 2 respectively. Original case means something like this. This is what the original case. The total reactance is X. The midpoint voltage here, sending end voltage V, receiving end voltage V. So what is P max now in the first case? V square by X. In case 1 means we maintain midpoint compensation. This is an example of midpoint compensation. If this is X by 2, V, V and V. Now what is the P max now? V into V, V square by what? X by 2. So 2 into V square by X here. Now in the last case, this is the story. 0.75x and this is 0.25x. Because the voltage is maintained constant at what? 75% distance from the sending end. So in this case, what is the phi max? Maybe you are thinking that v square by 0.25x, that is very high compared to what v square by 0.75x. So you have to select minimum v square by 0.75x. Now if you find out the ratio, what do you get? 1:2:1 by 0.75. So the option is what? B. 1:2:1 by 0.75. Now we'll move on to the next question. The grading of the cables is performed in order to achieve. See, the grading of the cables is done why? To get either uniform stress or to reduce what? The total amount of insulation. Means quantity of insulation, not quality. So 1 and 2 are correct. Not quality of insulation. Quantity of insulation we can reduce with the help of what? Grading. So that's why the option is A. Now let's see this question. Self impedance and mutual impedance of transmission line is given and asking to calculate what is positive, negative and zero sequence impedances. See, the formula is very simple. See, Z1 equal to Z2 for transmission line, Zs minus Zm. What is Zs? Given 0.8, Zm given 0.2. So Z1 equal to Z2 equal to, we get 0.8 minus 0.2, which is what? 0.6. Now what is Z0? Zs plus 2Zm. So Zs is what now? 0.8, 2 into 0.2. So we get 1.2 per unit. So the option is D. 0.6, 0.6 and 1.2 per unit. Now we'll move on to the next question. At a particular node, the real power specified is, let's see, at this node, the real power leaving the node given 20 and 25. So total what? 45. Incoming is how much? 30 and 60 given. Means what? 30 and 60 means 90. That's why it is an unbalanced load now. Yes or not? 90 is coming, 45 is leaving. To get the balancing, what should be the power? Means what? Incoming equal to outgoing. So there should be an outgoing power of what? 45 megawatt. Then only balance will happen. Very simple question, common sense question. Incoming power 90, outgoing power 45. To have a balance, one more 45 should leave the node. So 45 megawatt leaving the node is the correct answer. We'll move on to the next question. Okay, this is a relays here and application of element here. Buckholes relay we know used for transformer protection. Yeah. Yes, the Buckholes relay for what? Transformer protection. Transfer relay for feeder protection. These two are enough to clear the answer. 1Q, 2P, 1Q, 2P. No. 1Q, 2P, only option D. Yes, directional relay means what? Ring main distribution system protection. You can verify. Negative sequence relay only used for generator protection against unbalanced loading. Carrier current protection means what? This is used for what? Long transmission line. Radial distribution is what? No relay is given here. Simple overcurrent relay used for protection of radial distribution system. So 1Q, 2P, 3U, 4T, yes or not? 4T and 5S. Next we'll move on to the next question. A three-phase transformer having a line voltage ratios are given. Primary star connection, secondary delta connection. 400, 33,000. Now the CT on LV side given 1000 by 5 ampere ratio. What is the CT ratio on HV side is asking. To calculate this, you proceed with the primary line current is 1000 ampere. What about the secondary line current? You can do it. VL1 IL1 equal to VL2 IL2. You will get this answer. But what is the secondary current now? 5 ampere. But here these three secondaries are forming what? Delta. The three CTs are joined to form delta, but here three CTs are joined to form star. Now the logic is that the pilot wire currents must be same. Tell me 5 ampere is what? Internal current of delta. What is external current? 5√3. Now logic is here also 5√3 current. That means what is the internal? 5√3 ampere. Line current and phase currents are same for star. That means what is this CT secondary current? 5√3 ampere. So what is CT ratio now? IL2 by 5√3. How to calculate IL2? Very simple. VL1 IL1 equal to VL2 IL2. Okay na? VL1 IL1 equal to VL2 IL2. Let's solve this. VL1 is what? 400, IL1 1000, VL2 33,000, IL2 we need to calculate. So what is IL2? 400 by 33. So 400 by 33 is the primary current. Divide with secondary current 5√3. Yes or not? Clear? So what I get now? 80 by 33√3. So you have to solve this, which will be approximately 1.4. So what is satisfying 1.4 is this. Okay. So the option is what? A. We'll move on to the next question. So in the inductance and capacitance of a power system is 1 Henry and 0.01 microfarad. The instantaneous value of current interrupted by the breaker is 10 ampere. Then the voltage across the breaker contact is, we have a direct formula for this. The voltage across the breaker contact is V equal to I into root over L by C. I is given 10 ampere, L is 1 Henry, and this is 0.01 into 10 power minus 6 microfarad now. So we get this what? 10 into what? Root over 10 power 8. So that means what? 10 into 10 power 4 volts means 10 into 100 into 10 power 3 volts means 100 kV. The answer is what? 100 kV. Now we'll move on to the next question. So in this question, let's see here. The incremental fuel costs are given. So, and the total demand also given 250. Neglecting the transmission losses, we need to calculate P1 and P2. How to calculate P1 and P2? By equating IC1 equal to IC2, right? Then only we get the minimum fuel cost. If we write IC1 equal to IC2, we get P1 equal to what? P2 plus 35. This is equation 1. Another equation is what? P1 plus P2 equal to 250. If you solve them, we get P1 equal to 142.5 and P2 equal to 107.5 megawatt. Direct question. Okay. But the point is that, so in this question, no option is matching this. So I can go with the best answer. P1 should be greater than P2. Yes or not? Because P1 equal to what? P2 plus 35. More than P2 power and P1 power if you compare. P1 power is what? More than 35 megawatt when compared with what? P2. Clear? So the best answer is what now? A. Yeah. Now we'll move on to the next question. A consumer consumes 600 kilowatt hours per day at a load factor of 0.4. Now to increase the load factor to 0.7 without increasing the maximum demand, what is the consumption in energy, consumption of energy in kilowatt hour is asking. Clear? So how to solve this? Very simple. See how much power the consumer is consuming? 600 kilowatt hours. So we know the load factor equal to what? Load factor 1, average demand by maximum demand. What is average demand? Energy by total hours. So total hours means with respect to day. So 600 by 24 divided with maximum demand equal to what now? Load factor 0.7. So what I get now? 600 by 24 divided with what? 0.7. That is what the maximum demand. Now the load factor of second case is increased to what? Yes, increase it to point. So this is 0.4, I am sorry. Now it is increased to what now? 0.7. So 0.7 equal to, we don't know what is the average demand now. Maximum demand is same. 600 by 24 means what? 25. 25 by 0.4. Okay. So what is the average demand now? 25 by 0.4 into 0.7. To calculate the energy, what? 25 by 0.4 into 0.7. You need to multiply with what? 24. If you do this, approximately we get 1050 kilowatt hours. So the answer is C. Clear? So first we calculated using average demand, what is the maximum demand. Using load factor, again we calculated the new average demand. We multiplied that with what? Total hours. So we got, so energy in kilowatt hours. We'll move on to the next question. Yes, it is required to melt 3 tons of steel using an electric arc furnace. The heat energy required to melt 1 kg of steel is what? 170 kilocalories. The electrical power utilized by the furnace is 510 kilowatt hours. Then what is the time required by the furnace is? See, to calculate the time here, very simple formula we need to use. The time equal to what? Energy by what? Power. Yes or not? So energy you calculate in kilowatt hours. How to calculate the energy? So we know that 1 kilowatt hour energy equal to 860 kilocalories. This is a relation. 1 kilowatt hour is nothing but 860 kilocalories. So how many kilocalories are required to melt 3 tons of steel? To melt 3 tons of steel, energy required is what? 3 tons means what? 3000 kg. Per kg 170 kilocalories. So 170 kilocalories. If you want to convert this into what? Kilowatt hours, you have to divide with what? 860. 3000 into 170 divide with what? 860. These many kilowatt hours. Divide with what? Power. What is power? 510. So time equal to what now? 3000. Sorry, this is 170, right? 170 whole divided with what? How much power? 510. So these many hours we get. So 1.16 hours we get. We solve this. So 1.16 hours means what? 1.16 hours means 1 hour 10 minutes approximately. So the answer is 1 hour 10 minutes. It's a common sense based question. To answer this question, you need this relation. Next question. The scheduled speed of a train over a level track is 30 kilometers per hour. The distance between the stations is 1 kilometer. And the station stopping time is 20 seconds. Okay, station stopping time is 20 seconds. Then average speed of the train is, so that means how much is the average speed of the train is asking. Okay, so how to calculate this? Very simple. So we know that to cover like 1 kilometer distance, what is the speed we required? And the halt time is what? 20 seconds, right? Okay. So what is the time required here? We need to calculate. Okay. So that means the time required to travel 1 kilometer distance is what? 1 by V average. That is equal to, okay, this plus what? 20 by 3600. This is in what? This is hours, this is also hours, equal to what? 1 by 30 kilometers per hour. This is in 1 kilometer per hour. So that this is also hours. Okay. Now we get what? V average. So what is V average? If I solve this, 1 by 30 minus 1 by 180. So 6 minus 1 if you do LCM. 5 by 180. That means 1 by 36. So what is V average? Average speed 36 kilometer per hour. So the answer is what? C. Yeah, this is the direct question. The specific energy. Okay. So the specific energy units are what? Watt hour per, tons kilometers. So that's why the answer is what? Sorry. For this question answer is D. S equal to T by WD. Specific energy S equal to what? T by WD. Now next question. So yes, a balanced supply, 3-phase 4-wire system is supplying a balanced star connected load. Load impedance also given. The only thing you need to cross verify is this voltages are balanced or not? Yes, these voltages are balanced. How to verify that? So you have to bring it to what now? Okay. So reference here. If you want to bring it to reference of A phase, you have to add 900 degrees to all the voltages. 900 degrees if you add, first voltage is what? This 230.9 at an angle 0. Second voltage is what? 230.9 at an angle plus 600. Third voltage 230.9 at an angle what? Minus 600. Now to bring an angle which is what? Close to 180, you can add 360 once or twice, it's up to you. But what I can do here, minus 720 I will add. What I get now? 230.9 at an angle minus 120. Here plus 720 you add it. 230.9 at an angle plus 120. So first thing what? This is what? Angle 0 minus 120 plus 120. That means I confirmed that the voltage is also balanced. Load is balanced, voltages are balanced, currents also balanced. For a balanced case, the neutral current is always 0. So that's why the option is what? B. Okay, clear? So with this, we finish the questions on power systems, utilization of electrical energy, as well as what? Three-phase circuits. From utilization of electrical energy, 3 questions given in AP TRANSCO 2019 paper, and three-phase circuit 1 question was given, and from power system almost 14 questions are given. So all the best. Thank you.
Hi students, in this video, now let us look into solutions to power electronics of AP TRANSCO 2019 paper. Now the question is, for an SCR during turn on and turn off, the quantities responsible respectively. So if you look into SCR turn on and turn off process, we know that in the forward characteristics, we can say whenever SCR is forward biased, by supplying gate current until anode current crosses latching current, then SCR will get turn on. On the other side, in order to turn it off, we should reduce anode current below holding current. Therefore, for turn on process, latching current is an important specification, and for turn off process, holding current is an important specification. Therefore, for this question, latching current and holding current respectively, that will be the correct answer. If you want me to write down here, latching current corresponds to turn on transition and holding current corresponds to turn off process. And of course not the part of the question. During turn on process, SCR should be forward biased. During turn off process, SCR should be reverse biased. Now let us move to the next question. A particular power electronic controller develops a symmetrical output voltage from pi by 6 to pi radian, 7 pi by 6 radian to 2 pi radian across a resistive load over a cycle. The circuit contains. Now, by the given information, suppose if I draw voltage across the resistor, what it is mentioned that, let me say voltage across resistor is the output voltage. It mentioned that output voltage is present from pi by 6, that is 30 degree, to pi radian. Okay, so here this is a pi by 6 and this is pi. Next, from 7 pi by 6, what he meant by 7 pi by 6? Pi plus pi by 6, that is here. So from 7 pi by 6 to 2 pi radian across a resistive load. Therefore, 7 pi by 6 to 2 pi means we can have a waveform like this. So this is a 7 pi by 6 to 2 pi. So we can have this type of voltage across the load whenever the circuit has two possibilities. One is two SCR in anti-parallel, two thyristors in anti-parallel. So basically the given circuit is AC voltage controller, and this combination is equivalent of a triac. This combination is equivalent of a triac. Therefore, answer will be triac. For this question, answer is triac. I hope it is clear. Next, a single phase midpoint full wave SCR converter with a maximum midpoint voltage of V max volt develops an average output voltage across a resistive load at a firing angle delays of 0 and pi by 2 radian respectively. Now, the given circuit is midpoint full wave SCR converter. Whether it is a full wave midpoint circuit or bridge circuit, expression for average output voltage is same. So, if you write average output voltage equation, when the load is resistive here, remember, load is resistive. When load is resistive, average output voltage across this full wave rectifier will be Vm by pi into 1 plus cos alpha. Remember, generally this midpoint converter or full wave rectifier means mostly students will try to apply this formula 2 Vm by pi cos alpha. You cannot use this formula for this particular case. This Vm 2 Vm by pi cos alpha, this equation is applicable only for current stiff load. But here the load is given resistive. Therefore, we have to use Vm by pi into 1 plus cos alpha. Now, if alpha is equal to 0 degree, in this case, V0 will be 2 Vm by pi, because alpha 0 means cos alpha will be 1, then it will be 2 into Vm by pi. Next, when alpha is equal to pi by 2, when alpha is equal to pi by 2, cos pi by 2 will be 0, therefore average output voltage is equal to Vm by pi. So, where Vm is nothing but Vmax. So, for this question, first option will be correct. 2 Vm by pi when alpha is equal to 0, Vm by pi when alpha is equal to pi by 2. Now, let us move to the next question. Is 240, students remember, for this question, options are not matching. There is no answer for this question, but I will explain how to solve this. A 240 volt 50 Hz single phase half wave SCR converter supplies a resistance load at a firing angle delay of pi by 3 radian. The RMS load voltage is. Now, in this case, suppose if you write down expression for VOR square, integration can be written as 1 by 2 pi integral from alpha to pi square of the function, that will be Vm square sin square omega t d omega t. Now, if you simplify this, it will give you Vm square by 2 pi integration from alpha to pi sin square omega t can be expressed as 1 minus cos 2 omega t d omega t. So, from here you will get, by simplifying this, I am not doing all the steps, RMS voltage can be written as Vm divided by 2 root pi multiplied with pi minus alpha plus 1 by 2 sin 2 alpha under root 1 by 2 sin 2 alpha under root. Now, by substituting the numericals, VOR is equal to, where Vm is 240 root 2 divided by 2 root pi, and alpha is given pi by 3, therefore pi minus alpha will give you 2 pi by 3 plus 1 by 2, pi by 3 means 60 degree, and sin 2 alpha means sin 120 degree. Sin 120 degree will be same as sin 60 degree. Therefore, this value will be root 3 by 2 under root. Now, this in that 2019 paper, for this question, marks to all was given. But the correct answer for this question will be this numerical. Okay, as calculator is not allowed, I am just leaving here. If you are interested, you can just calculate and check what is the number. Next, a single phase half wave controlled SCR converter with a commutating diode supply an RL load at an average load voltage of 150 volt. Here you can make a note, commutating diode is simply nothing but another name for freewheeling diode. Okay, commutating diode means freewheeling diode. So here basically the circuit will be something like this: single phase half wave rectifier, SCR converter. Therefore, there is some load here, and there is a commutating diode which is also referred as a freewheeling diode. That is the circuit diagram. Supplying an RL load at an average load voltage of 150 volt at a firing angle delay of 60 degree. Now what is the supply voltage to the converter? So here, what could be average output voltage with freewheeling diode? This will be Vm by 2 pi into 1 plus cos alpha. This voltage value is given 150 volt. Now we need to find what is Vm. So Vm divided by 2 pi, as alpha is given 60 degree, cos 60 will be 1 by 2. Then it is 3 by 2 is equal to 150. Therefore, Vm is equal to 150 into 4 pi divided by 3. 3 here it will cancel 50 times. Therefore, the answer will be Vm is equal to 200 into pi in volt. So there must be some clarity required for this question. It is mentioned that supply voltage to the converter. It is not given that whether it is RMS voltage or not. So with that you can take Vm is equal to 200 pi. If it is a supply voltage RMS value, you can take 200 pi divided by root 2. So is there any answer is matching? 200. So supply voltage, I can say Vs is equal to 200 pi divided by root 2. So this will be, if you multiply and divided with root 2 here. So this is 100 into root 2 into pi. So as none of the option is matching with that, so we can take peak value of the supply voltage, that is 200 into pi volt. Now let us move to the next question. A separately excited DC motor controlled by a single phase SCR full converter at 200 volt AC voltage draws 40 ampere current at a firing angle of 45 degree. If the armature resistance of the motor is 0.25 ohm, then what is the back EMF? Now, a DC motor is controlling by single phase full converter. Therefore, terminal voltage to the motor will be output voltage of the converter circuit. That is 2 Vm by pi into cos alpha. Now, as alpha is given 45 degree, let us calculate this first. 2 into AC side supply voltage is 200 volt. Therefore, 200 into root 2 will be Vm divided by pi into, as alpha is 45 degree, cos alpha will be 1 by root 2. So, from here you will get V0 is equal to root 2 cancel, and this value will be 400 divided by pi in volt. Next, now if you apply simple DC motor equation, terminal voltage can be written as back EMF plus armature voltage drop. Therefore, 400 divided by pi is equal to back EMF plus the load draws 40 ampere. That means armature current will be 40 into 0.25. That is the armature resistance. Therefore, from here if you simplify, we will get back EMF is equal to 400 by pi minus 10 in volt. So this is the answer. So back EMF is equal to 400 by pi minus 10 volt. Now let us move to the next question. in an adjustable speed DC drive operated by an AC to DC converter with armature voltage up to base speed. Even though just the word AC to DC converter is used, by simple missions concept you can answer this one. With armature voltage control up to base speed. Up to base speed, what is the basic concept here? The torque remains constant and the speed will increase with the help of voltage control. See, armature voltage control is simply nothing but voltage control. So for this question, the torque remains constant and speed will be increasing. Next, let us move to the next question. So this is a very interesting question. The conducting pairs of SCRs in a bridge type 3-phase AC to DC converter with the SCRs S1, S3, S5 connected in the top half and S4, S6, S2 in the bottom half of the converter and supplying a resistance load R. Now, it's very nicely framed. Circuit diagram is not given. From the statement, you should be able to draw circuit diagram. So, what is that 3-phase AC to DC converter? I always emphasize you should focus on basics clearly. So, not only formulas and waveforms, even circuit diagram also, the question is framed just based on the circuit diagram. So, this is how the bridge rectifier is. Now, the load is resistor. So, here what is mentioned 135 in the upper half. This is what I used to follow in the class. 462 in the bottom half. This is the devices numbering. Now, suppose if you recollect the device sequence, conduction sequence diagram. This question is mainly based on conduction sequence diagram. So, what will be the sequence? Each device will conduct for 120 degree. Now, I am not specifying any firing angle because question also not mentioned that. And if you able to recollect conduction sequence diagram, you can have numbering like this: 1, 3, 5 in the upper half, 4, 6, 2 in the lower half. So, this is how the conduction sequence diagram looks like. So, what are the pair of conduction devices? What is the sequence? Sequence is the question. Now, if you see here, this is one combination. Now, this is a 1, 4 is one combination. After that, 4, 3 is another combination. So, in this way, if you try to observe this pattern, 1, 4, otherwise I will use arrows like this. This will be more clear. 1, 4, this is a one pair. 4, 3, next pair. 3, 6 here. 6, 5 here. 5, 2, and then here you will have again 1. So, you will have a 2, 1. Okay, so this one. So, this will be the answer. That is the sequence. Now, see how nicely the question is framed. It is based on just a circuit diagram and conduction sequence. There is no waveform, no formula, nothing. Only you need to understand the working principle of the circuit diagram. So, if the examiner is a smart, we don't know how we can frame a question in power electronics. Just based on the circuit diagram and the conduction sequence of the devices. Now, in this particular 2019 paper itself, the questions are mostly on this conduction sequence. There are 3 questions. We will see next also. Now, this is another question, but this is based on the inverter circuit. A single phase full bridge inverter with switches S1 and S2 in one leg, one leg or one pole. S3 and S4 in the other leg, connected along with feedback diodes D1 and D2 and D3 and D4 respectively, develops a square wave voltage across RL load, across an RL load. The conducting devices carrying currents during the time intervals T0 to T1, T1 to T2, T2 to T3, T3 to T4. Now, in this question, you should draw circuit diagram as well as waveform also. Then only you can answer the question. What is the given circuit? Single phase, full bridge VSI. So, it is mentioned that S1 and S2 in one leg, S3 and S4 in other leg. This is the circuit diagram. S1, a freewheeling rod is D1, S2, D2, S3, D3, S4, D4. If you following my lectures, this sequence is different from what I used to take in the class. However, but based on this sequence we should able to answer it. So, V0 will be measured from A with respect to E and I0 will be measured, positive I0 will be taken as from A to B. Suppose in this case V0 and I0 waveforms will be like this. First let me draw that waveforms. V0 and I0, this is output voltage, square waveform. In this particular circuit, this is how output current waveform is, right? Now, what is mentioned here, T0, T1, T2, T3, T4, that is the one cycle. So, in this case, again, see here, entire single phase VSA operation, you should be thorough with it. Okay. So, here S1, S4 is one combination. D1, D4 will be the next combination. S3, S2 will be the next combination. And D3, D2 will be the next combination. This is the combination. Okay. So, here if S1 and S4 pair is conducting, low terminal A will be connected to positive side of the source, B will be connected to negative side of the source. In that case, V0 will be positive and the direction of output current will be from A to B. So, I0 is also positive. Whereas, when D1, D4 are in conduction, there is no change about output voltage, hence V0 is positive, but I0 will flow from B to A. In that case, I0 will be treated as a negative. In the similar side, if you continue with S3, S2, you will have like this. Okay. Now, what is the question here? From T0 to T1, what are the devices? Finally, you have to figure out that devices pair. So, T0 to T1, I0 is negative but V naught is positive, I naught negative, V naught positive. So in this interval, D3, D4 will conduct. So here T0 to T1, it develops a square wave voltage across an RL load. The conducting devices carrying currents during the time intervals T0 to T1. Okay, so I'm sorry here, not D3. I'm sorry, this is why confusing. D1, D4. I'm sorry. Here, as per the table, this will be D1, D4. Next, from T1 to T2 interval, both V naught as well as I naught are positive. Therefore, S1, S4 will conduct. If you are following my lectures, this sequence is different from our notes. T2 to T3. From T2 to T3, V naught is positive. V naught is negative, but I naught is positive. Therefore, here D3, D2 will conduct. D3, D2 will conduct. From T3 to T4, both are negative. So, S3, S2 will conduct. Therefore, what is the sequence here? D1, D4 and S1, S4, D2, D3 and S2, S3. So, this option B will be the correct answer. Now, let us move to the next question. This is also another question on sequencing. Okay, so in 2019 paper, there are 3 questions only on sequence. Next, the sequence of triggering of SCRs in a 3-phase bridge type converter with SCRs S1, S2, S3 connected in top half and S4, S5, S6 in bottom half of the converter. Now here, the device's names has been changed, but the standard practice is 1, 3, 5 in the upper half, 4, 6, 2 in the lower half. Now same explanation is applicable for 3-phase inverter also. Next, what is mentioned here, but in the upper half it is given S1, S2, S3. So what you have to do, write down the corresponding devices names S1, S2, S3 and lower half 4, 5, 6. S4, S5, S6. Now, what is the conduction sequence of triggering, right? Therefore, what is the sequence here? Standard sequence 1, 2, 3, 4, 5, 6. Now, 1 has to be replaced with S1, 2 should be replaced with S6, 3 should be replaced with S2, 4 is S4, 5 is S3, 6 is S5. 6 is a S5. So the sequence is S1, S6, S2, S4, S3, S5. This is the answer. I hope it is clear. This is the way you need to follow if any different sequencing is given. Now the same approach is applicable for same approach. Same approach for 3-phase full converter, that is rectifier circuit, and also 3-phase inverter. For 3-phase rectifier as well as 3-phase inverter, the same approach. Next, for a DC to DC boost converter circuit, the order of connection of components L, C, D, MOSFET switch in between supply and load from left to right. So instead of mugging up these things, if you simply draw boost converter circuit, you can answer it. You just only need to draw circuit diagram. This is inductor, source voltage, switch here. This is how diode is. And there is a capacitor. This is a circuit diagram for boost converter. Now, from left to right, what we have to take? Inductor is in series. Inductor is in series. Switch is in parallel. Diode is in series. C is in parallel. That's it. Only thing is you should able to redraw circuit diagram. Now the next question, in a DC to DC buck converter, when the MOSFET switch is triggered, the rate of change of current in the 400 microhenry inductor is 7.5 into 10 power 4 ampere per second. If the converter is operated with a 50 volt input voltage, what is the output voltage of the converter circuit? Now, of course, circuit diagram is not required if you remember the formula, but however, just for ease of explanation, let me draw circuit diagram for buck converter. This is the switch. There is a diode like this, an inductor, a resistive load, and capacitor. Now source voltage is VDC. Let us assume output voltage is approximately constant by having a large capacitor across the load. Now let us take an inductor current of IL. So here when the switch is turned on, when switch is on, L into DIL by dt, L into DIL by dt is equal to VDC minus V0. Therefore, DIL by dt not required here. Let us substitute the numbers directly. Inductance value is given 400 microhenry into DIL by dt is given 7.5 into 10 power 4 is equal to VDC, source voltage is given 50 minus V0. So 400 into 10 power minus 6 is nothing but 4 into 10 power 4. So 10 power 4 will cancel. Sorry, 4 into 10 power 4 minus 4. So 10 power minus 4, 10 power 4 both will cancel. Then 4 into 7.5. This is a 30 is equal to 50 minus V0. Therefore, V0 will give you 20 volt. So answer will be option B. So these are the different questions given from power electronics. So if you see all the questions in this particular paper, from all chapters, the question is covered. Okay. So this first question is based on the devices topic, and this is a rectifier. This is AC voltage controller, and this is a rectifier. This is also rectifier. This is rectifier. This is a rectifier and drive question. This is one drives question, and this is a bridge circuit. There are 3 questions just purely based on this sequence. This is an inverter question, and this is again rectifiers question. This is a DC to DC converters question, and this is also DC to DC converters. With this, these are all the power electronics questions from 2019 AP TRANSCO paper. With this, thank you, and I wish you all the best.
Alright guys, now let's discuss the questions from network theory or circuit analysis. Look at the first question, in steady state. In fact, they should have said at steady state, not in steady state, at steady state. What will be the capacitor C2 voltage? That means voltage across this capacitor if C1 equal to C2. So the two capacitors both are identical in terms of value in the circuit given below. So there is a simple circuit that is given, and the source is what? A DC source. So any circuit driven by DC source will obviously reach what? DC steady state. So the question is what? At DC steady state, what is the voltage across C2? Also given that the two capacitors are identical. Okay, it's very simple actually. At DC steady state, any capacitor will behave like an open circuit. So what happens is C1 it becomes open, C2 also it becomes open. You see, when C1 becomes open, no current will flow through what? C1, and also no current will flow through what? C2, because C2 also becomes open. Hence, no current will flow through R as well, which means the drop across R would be 0. And since C2 is in parallel with R, even the voltage across C2 will be 0. Then, whatever is the source voltage, which is V in this case, will entirely drop only across C1. Yes, so if you are thinking that because both the capacitors are identical, this voltage will get equally divided between C1 and C2, then you are mistaken. Okay, so this entire voltage at DC steady state will only drop across C1. Okay, and the drop across C2 would be 0. So what is the correct answer? It is 0 and not V by 2 or something like that. Okay. Well, moving on to the next question. What will be the rise in the capacitor voltage per second? Rise in capacitor voltage per second. So indirectly they are asking the value of dVc by dt, rate of increase in the voltage across the capacitor in this simple circuit. In fact, in this circuit there is a voltage source and a current source connected in series with the capacitor. Since this element is what? A current source, that current will directly flow through the capacitor. So what is the current through the capacitor? It is 2 amperes. Okay, and if you call the voltage across the cap as what? Vc, and if you call the current through cap as what? Ic, and of course Ic is equal to what? 2 milliamps. So what is that current voltage relationship for a capacitor? You know, Ic equal to what? C dVc by dt. But our question is what? To find dVc by dt, which is Ic by C. So Ic is what? 2 amperes, and the capacitance is what? 2 micro farad, which is 2 into 10 power minus 6 farad. 2 and 2 will get cancelled, and 10 power minus 6 will go to what? Numerator to become 10 power 6. So the correct answer is what? 10 power 6 volts per second. Okay, or you can say 1 volt per microsecond. Okay, I mean none of these options is matching our answer, but I suppose in the options, I mean in the units, that microsecond in the denominator is missing. Instead of microsecond, they have mistakenly written second. So had it been microsecond, then the answer would be what? Option A. But then this has to be 1 volt per microsecond. Okay. Moving on to the next question. Some network is given. If R1 equal to R2, that means this resistor and this resistor both are identical. What should be the voltage magnitude to have 0 current through R3? What is the requirement? The current through R3 has to be 0, and for that, what should be the value of this voltage source, or what is the magnitude of this voltage source supposed to be for this current through R3 to be 0, and then the other constraint is what? R1 and R2 are equal. Okay, So let's solve it. It's a simple question. So what is the requirement? Current through R3 has to be 0, which means drop across R3 will be 0. And because it is given that R1 and R2 are identical, let's say this is some R, then there is also some R. There is no ground in this circuit. Let us assume this to be ground. Okay. Then the voltage at this point will be 0. Here it would be 0. Sorry, 5. Here it would be 0, and here it would be V. Okay. Then what is the current through this R1 from left to right? Ohm's law, 5 minus 0 by R, which is 5 by R. Similarly, what is the current through R2 from left to right? Again, Ohm's law, 0 minus V by R, which is minus V by R. Now, if you try to write KCL at this point, from the left, this current is what? Incoming, and on the right side, this current is what? Outgoing. So, if you write KCL at this point, you will get 5 by R equal to what? Minus V by R. So, the value of V is what? Minus 5. But the question is what? To find the voltage magnitude. So, what is the magnitude of the voltage value of this voltage source? It is plus 5. So, the answer is what? Plus 5. Okay. And that is what? Option B. Because in the question, they have clearly mentioned magnitude. You should not choose minus 5. Even though the actual value of the voltage source is what? Minus 5. Still, your answer is what? Plus 5. Since the question is what? To find magnitude. Okay. Moving on, let me read the question. A series RL circuit. So, we have this resistor and the inductor both connected in series, is excited at t equal to 0 by closing a switch. So, this switch is being closed at t equal to 0, which means before t equal to 0 or for t less than 0, the same switch is going to be open as shown in the figure. Assuming 0 initial conditions, I mean, what is the only initial condition in this network? It is the initial current through inductor. Okay, that is IL of 0, and that IL of 0, they are asking you to assume IL of 0 to be 0. The value of d square I by dt square at t equal to 0 plus. So, what is I here? I is what? The loop current. In fact, I is same as what? IL. I is what? Same as IL. And the question is what? To find the second derivative of this I, or the second derivative of IL, since I is equal to what? IL at t equal to 0 plus. See, for this, you just have to use the voltage current relationship for the inductor. So, all of you know very well that for the inductor, VL equal to what? L times DIL by dt. Yes or no? VL equal to what? L times DIL by dt. Now, DIL by dt can be written as what? VL by L. And then if you differentiate both sides with respect to time, it will become d square IL by dt square equal to what? 1 by L times dVL by dt. Okay, so that is one way to find the value of d square IL by dt square. So, to find d square IL by dt square at t equal to 0 plus, you need to find the value of dVL by dt at t equal to 0 plus, and then that value multiply it with 1 by L, that is going to be our answer. Okay. Or else another thing that you can do is what? You can easily write down IL as a function of time for t greater than 0. Okay, using that final initial formula, and then you can differentiate that IL twice with respect to time, and then because the question is what? To find the value at t equal to 0 plus, you just substitute t equal to 0. That is also one way to do it. So, let's get the answer. So, there is the circuit, right? So, the current through inductor, I am going to call it IL, and for t greater than 0, the switch is going to be closed, and this RL circuit is driven by a DC voltage source. So, if you try to write an expression for IL of t, for which you need to know the initial and final values of IL. So IL of 0 is same as what? IL of 0 plus is same as what? IL of 0, and the initial condition for the inductor is what? 0. What about IL of infinity? At t equal to infinity, circuit reaches what? DC, steady state, where the inductor becomes what? Short circuit. Then the only resistance in the loop is what? This resistance R, and then the loop current will be what? V by R. So that will be the final value of IL. And what is the time constant? It's a simple RL circuit. So tau will be what? L by R. That's all, using the initial, final value, final value, and the value of tau. You can write down IL as a function of time. Final plus initial minus final times e power minus t by tau. Final value is what? V by R. Initial value is what? 0. Again minus V by R times e power minus t by tau. In place of tau, you should write L by R. And from this, what do you get? V by R minus V by R times e power minus t by tau. Now what? We need to differentiate this IL with respect to time. How many times? 2 times, because the question is what? To find d square I by dt square, which is same as what? D square IL by dt square. So I'll just change the color. So if you differentiate this expression with respect to time, then you will get dIL by dt. The first term is what? V by R, that is independent of time, so the derivative would be 0. What is the derivative of the second term? It will be V by R tau times e power minus t by tau. Once again, you differentiate both sides with respect to time, so that you get the expression for d square IL by dt square. So once again, if you differentiate, you will get minus V by R tau square times the same exponential e power minus t by tau. Now you need to evaluate both the sides at t equal to 0 plus. T equal to 0 plus means what? Just after t equal to 0, but the value of t is nearly equal to what? 0. So to find anything at t equal to 0 plus, still in place of t, you have to substitute 0 only. Okay. Again, I'll change the color. So put t equal to 0. When you put t equal to 0, the exponential will become what? 1. So the answer will be what? Minus V by R tau square. Now we know tau is what? L by R. So tau square will be L square by R square. So R square will go to numerator. R square by R is what? R. So you are going to get minus VR by L square. This is the value of d square I by dt square at t equal to 0 plus, minus VR divided by L square, which is what? Option D, minus RV upon L square. So you just have to be systematic. Okay. Fine. Moving on to the next question. Determine the current through the capacitor during steady state. Again, this circuit is driven by what? A DC source. So eventually it will reach what? DC steady state. And you know, at DC steady state, inductor becomes short. In fact, both the inductors will become short. The capacitor becomes open. What is the current through an open circuit? 0. In fact, the question is what? Determine the current. So you don't have to do anything. Directly you can say it is what? 0. So the current at DC steady state will only flow like this and not through the capacitor. Okay. Look at the next question. What will be the shape of current in the circuit? So they are referring to what? The loop current, or the current through the inductor. So what is there in this circuit? There is one coil or inductor with inductance L driven by two sources connected in series. One is what? An AC voltage source of value Vm sin omega t. Another is what? A DC voltage source of value VDC. Okay. So obviously you have to use what? Superposition. Even if you don't use superposition, then also you'll get it. You can just use the voltage current relationship. Okay. Because see, nothing is, you can do it in a bunch of ways. If you use superposition, okay, you have to find the current when only Vm sin omega t is present, and then you should also find the current when only VDC is present, and then you add up the two currents. That is one way to find the current. Okay, but instead you can also use the voltage current relationship. Okay, in fact, look at the options. Okay, for current waveforms are given. Okay, it's not R of t, it's a typo. So each of these is what? Current waveform. You have to choose the appropriate current waveform. Okay, just by inspection also you can figure out what is the best option or what is the correct option. Okay, so if you apply a sinusoidal voltage across inductor, even the current will be what? A sinusoid. Okay, and then if you apply a DC voltage across inductor, there will be a continuous buildup of flux in the coil. That means there will be a continuous increase in the current through the coil. So the current will keep on increasing like a ramp. So due to DC voltage applied across inductor, there will be a constant rate of increase in the current, meaning the current will increase linearly like a ramp. And due to the sinusoidal voltage that is applied across the inductor, the current will also be what? Some kind of sinusoid. So the net current will be what? Sum of these two current components. One current is what? Like a positive ramp. Another current is what? A sinusoid. So the current is what? Summation of a ramp along with a sinusoid. So the answer has to be what? Option D. But still, you can work out the math and get the actual expression for the current. Okay. Let's say the current is what? IE, and voltage across the inductor, let's call it V. And what is this V? It is the DC voltage VDC plus the AC voltage, that is Vm sin omega t. And you know the relation between the current and the voltage. So I of t is what? The initial current through the inductor, that is I of 0 plus 1 by L integral V dt, of course from 0 to t. Now because in the question nothing is given about the initial condition, you can assume the initial condition to be 0. So I of 0, you can assume it is 0. Okay, so 0 plus 1 by L integral V dt. So in place of V, we should write VDC plus this sinusoidal component. So I'll do the integration separately. VDC dt from 0 to t plus again 1 by L integration from 0 to t Vm sin omega t dt. Okay. Now VDC being what? DC voltage, it is constant. It comes outside the out of the integration. Then integral dt from 0 to t is what? Just t. So VDC by L times t. So this is the ramp component in the current, which will linearly increase with a slope of VDC by L. And then when you integrate a sinusoid, you will always get a sinusoid. Okay. Anyway, if you want, you can write the precise expression. Vm comes out, and then Vm by L omega. Integration of sin omega t is what? Minus cos omega t. And then you integrate from 0 to t. If you plug the limits, I think you'll get, what is cos 0? It is 1 minus cos omega t minus 1. Okay. So in the end, you will get the following expression. So I of t equal to what? VDC t by L plus Vm by L omega. So if you try to evaluate this, upper limit, the value is what? Minus cos omega t minus the value of minus cos omega t at lower limit, that is 0, is what? Minus 1. Minus of minus 1, it would be plus 1. So it will be 1 minus cos omega t. That's all. Okay, this is the complete expression for I of t. So this is what? A ramp. This is what? A sinusoid. So the current is what? A combination of ramp and sinusoid. That is why we have already picked this as the correct option. Okay, fine. Moving on to the next question. What will be the average power drawn from voltage source? Okay, so look at this given circuit. There is this resistor R in series with a current source, also in series with a voltage source, and the question is what is the average power drawn from the voltage source? Even for the voltage source, there will be polarity, and that polarity should be mentioned. Okay, I guess it is mentioned in the actual question. Here it might be missing. Okay, that's all. So what is the current drawn from the voltage source? It is 1 ampere. Yes or no? Current drawn from the voltage source, it is 1 ampere, because voltage source is in series with the current source. So always the current drawn from the voltage source, or the current flowing out of the plus terminal of the voltage source, is what? 1 ampere. Okay, so what is the power drawn from the voltage source? It is the voltage times the current. Voltage is what? Vm sin omega t, and the current is what? 1, which is constant. Okay, voltage is what? Sinusoidal, which varies between Vm and minus Vm, but the current is a constant, always equal to what? 1 ampere. So this is the expression for the instantaneous power drawn from the voltage source. So if at all you try to plot the power drawn versus time, power drawn from the voltage source versus time, it will be a proper sinusoid. For a proper sinusoid, what is the average value? Because the question is what? To find average value, it is what? 0. There's nothing much to do in this question. Straight away you can say the average value of the power drawn from the voltage source, it is what? 0. Okay. Moving on to the next question. In the circuit shown below, this circuit, the values of I of 0 plus, I is what? The loop current, and I of 0 plus and I of infinity. That means the initial and final values of I, that is what they are asking, will be how much? Okay, some 4 options are given. I think there is a typo here. This voltage, or this input voltage, should have been 2 e power minus t u of t. Okay, not some c times minus t, c power minus t, it is e power minus t. Okay, but I don't think you need to do any kind of analysis. Just by looking at the source voltage, or the value of the source voltage, you can directly tell what are the initial and final values of I. Because look at the source, for t less than 0, e power minus t is not 0, but u of t, it is what? 0. So for t less than 0, if I call this Vi, like the input voltage applied to this RC circuit, this is what? A simple RC circuit. So for t less than 0, what is the value of Vi? It is 0. So is it not like a source free RC circuit? any source free RC circuit at steady state, everything will be 0. When I say everything is 0, even the voltage across the cap will be 0. Okay, so at t equal to 0 minus, at t equal to 0 minus, let me call the voltage across the cap as what Vc. So because for t less than 0, the value of the source is what? 0. It is like a source free circuit. Any source free circuit at steady state, everything will be 0. When I say everything is 0, it also includes the voltage across the cap. So what is Vc of 0 minus? It is 0. Okay. So what is Vc of 0 plus? It will always be same as what? Vc of 0 minus, which is 0. So at t equal to 0 plus, what is the voltage across the cap? It is 0. Okay, let me go to this circuit. So if I draw the circuit at t equal to 0 plus, at t equal to 0 plus, what is the value of the source, or what is the value of the input voltage? At t equal to 0 plus, that is just after t equal to 0, u of t will be 1. And e power minus t will also be 1, because t equal to 0 plus means what? You have to substitute t equal to 0. So when you put t equal to 0, e power minus t will be what? 1. So the value of the source is what? 2 volts. And then you have this 1 ohm resistor. And then you have this capacitor. Whereas the voltage across the cap at t equal to 0 plus will be what? 0. Yes or no? Because at 0 minus, voltage across the cap is 0. So at t equal to 0 plus also the voltage across the cap would be 0. Now what is the current? What is the current? I mean what is the net voltage in the loop? It is 2 volts. What is the net resistance in the loop? 1 ohm. 2 volts by 1 ohm is what? 2 amperes. So what is the current, or the loop current at t equal to 0 plus? It is 2 amperes. Okay. And then at t equal to infinity, at t equal to infinity, the value of the input source, because the value of the input source is what? An exponentially decaying voltage. Okay, 2 e power minus t. U of t will be 1, but your e power minus t will exponentially decay. So as t tends to infinity, the e power minus t will tend to what? 0. So Vi becomes 0. That means after a long time, again it becomes what? A source free circuit. Any source free circuit at steady state, everything will be 0. That means the current will be 0. Okay. So what is I of infinity? It is 0, because as t tends to infinity, again our circuit becomes what? A source free circuit. And if a source free circuit reaches steady state, everything becomes 0. Voltage across the cap, current through cap, voltage across resistor, current through resistor, everything becomes 0. Of course, always there will be exceptions, but there is not any exceptional case. Okay. So what are the values of I at 0 plus and at t equal to infinity? I of 0 plus is what? 2. I of infinity is what? 0. I of 0 plus is 2 and I of infinity is what? 0. So the correct option is what? Option D. Okay. Fine. Moving on to the next question. If the voltage across the resistor, okay, this resistor is equal to the supply voltage. What is supply voltage? Vm sin omega t. What will be the ratio of voltages, absolute values between L and C? See, when will the entire, this is what a series RLC circuit. It's on RLC, all are in series, connected across what? An AC source of value Vm sin omega t. Okay, this you can call Vi. And the voltage across the R, you can call it VR. And what are they telling here? Voltage across resistor is equal to supply voltage. That means VR equal to Vi. Indirectly, they are telling you that this circuit is under resonance. Okay, so the entire input voltage or the source voltage will drop across resistor only at resonance. Okay, so network at resonance, and obviously there is what series resonance. Okay, so at resonance, LC combination will behave like a short circuit. I'm not saying L and C will behave like short circuit. L and C together, okay, that LC combination will behave like a short circuit. Okay, so if you want, you can call the voltage across inductor as what VL, voltage across capacitor as what VC. So if LC is short, then the net voltage across LC combination would be 0. That means VL plus VC is what? 0. That means VL equal to minus VC. The question is what will be the ratio of voltages absolute? That means what is mod VL by mod VC? The answer is what? 1. Yes or no? VL and VC, they'll have same amplitude, but they'll be having opposite sign. They'll be 180 degrees out of phase, but the ratio of the two voltage magnitudes will be what? 1. Okay. So the correct answer is what? 1. Okay. Moving on to the next question. A high Q quartz crystal exhibits series resonance at the frequency omega s and parallel resonance at the frequency omega p. So there is a quartz crystal for which the series resonance frequency is what? Omega s, and the parallel resonance frequency is what? Omega p. So if you are familiar with the crystal, this is the schematic symbol of a crystal, and they are saying for this crystal, the series resonance occurs at a frequency of omega s, and for the same crystal, they are saying parallel resonance occurs at a frequency of omega p. And then 4 options are given, and they are about the relation between omega s and omega p. So first option says omega s far less than omega p. Option B says omega s far greater than omega p. And C option says omega c is very close to but greater than omega p. D option tells omega s is very close to but less than omega p. So first of all, what is the equivalent circuit or equivalent network of a crystal? Okay. So let's say you have a crystal between two nodes A and B, or between two terminals A and B. Now the equivalent circuit can be drawn like this. So you will have two branches. One branch will contain RS, LS and the series capacitance CS. And in parallel with this branch, there will be a shunt capacitance. And that is, the shunt capacitance is due to what? The externally connected load. Even if you don't connect a load, still the package itself will offer this shunt capacitance. Okay. This is the simple equivalent circuit of a crystal. So as you can see, there are two branches. One branch contains RLC in series. Another branch contains only one capacitor CP, which is called the shunt capacitance, which is the combination of the package capacitance and the load capacitance, if at all you connect something across the crystal. Okay. And a more simplified version of the crystal, since you are only looking at the two resonance frequencies, series resonance and parallel resonance, we can ignore RS, because usually RS will be really small. Okay. So this RS, let us just ignore it. Then the first branch will contain what? Only LS and CS, and the second branch that is in parallel will have what? Only CP. Okay. So when you neglect RS, the equivalent circuit for the crystal gets simplified like this. So you have LS then you have CS, and then you have CP. Now for this network, there will be two types of resonance. Okay, one is series resonance, another is what? Parallel resonance. Okay, so at series resonance, the impedance, the net impedance of this crystal will become minimum, and under parallel resonance, the net impedance will be maximum. Okay, in fact, if you are familiar with resonance, this LC combination, the first branch LC combination, if it is at series resonance, doesn't that LC combination behave like a short circuit? So once this LS and CS combination becomes a short circuit, then what is the net impedance? Anything across short circuit can be removed, then the net impedance of this crystal would be 0. That is series resonance condition, where the equivalent impedance is going to become 0. Okay. So anyway, let us say for the first branch, the net impedance is what? Z1. And for the second branch alone, which contains CP, the net impedance, let it be Z2. Okay. Now for the overall crystal, what is the impedance? It will be Z1 parallel Z2. Yes or no? So Z equivalent is obviously Z1 parallel Z2. Now the thing is what? Your Z equivalent will become minimum when the crystal is at series resonance, and it will become maximum when the crystal is at parallel resonance. Okay, so already series resonance occurs when the first branch acts like a short circuit. Okay, so what is the series resonance frequency? It is same as resonance frequency of the first branch. For any branch that contains L and C in series, what is the resonance frequency? 1 by square root LC. Okay, so omega S, which is the series resonance frequency, is same as what? Resonance frequency of the first branch, which is 1 by square root Ls times Cs. Now you just need to find the other resonance frequency, that is what? Omega P. So this is omega S and this one is omega P. And to find the parallel resonance frequency, you need to find what is the equivalent impedance. Okay. So what is Z1? I think, okay, what I'll do first is to separately write what is Z1 and what is Z2. Z1 is what? S Ls plus 1 by S CS. Okay. Whereas Z2 is what? 1 by S CP. And then what is Z equivalent? It will be Z1 parallel Z2, which means SLS plus 1 by SCS times 1 by SCP upon SLS by 1 by plus 1 by SCS plus 1 by SCP. Now for the denominator, what is the LCM? SCS into SCP. Numerator, what is the LCM? It is just SCS. So when you take LCM for both numerator and denominator, SCS times SCP will get cancelled. Okay, and you are going to get this 1 by 1 plus S square LSCS upon S cube LS CSCP plus S times CS plus CP. This is what you will get. Okay. Okay, in the denominator, I think S is common to both the terms. Okay. Fine, I'll write this on the next slide. So Z equivalent is what? 1 plus S square LSCS. Correct, right? 1 plus S square LSCS. Denominator, you have S cube LSCS CP. Plus S times CS plus CP. Okay. So this can be written as what? 1 plus S square times LSCS upon, if I take out S as common, then I'll have S square. I mean, what is S square? S is what? J omega. S square can be written as what? Minus omega square. So first I'll write CS plus CP thing. Minus S square, I mean plus S square, which is minus omega square, times LS times CS times CP. Now, at parallel resonance, we want Z equivalent to be maximum. Z equivalent can become maximum when denominator becomes 0. Okay. In fact, Z equivalent can tend to infinity, right? So if you observe, this Z equivalent can become infinity when this factor becomes 0. That means CS plus CP equal to omega square LS CS CP. So what is omega square? CS plus CP upon LS CS CP. So what is the parallel resonance frequency? In fact, you know, CS CP upon CS plus CP is like the equivalent capacitance if at all you have CS and CP in parallel. Okay. So 1 by square root of LS times CS CP upon CS plus CP. That's all. So I think earlier we wrote omega S, the series resonance frequency, as what? 1 by square root LS CS, and the parallel resonance frequency is what? This. Okay. Now usually what happens is your CP will be much bigger than CS. I repeat, CP will be much bigger than CS. Okay. Usually CP will be much bigger than CS. Now if you call this as the equivalent capacitance, then your equivalent capacitance is nearly equal to what? CS. So it is like having two resistors in parallel, where one resistor is what? Much bigger than the other resistor. Then the equivalent resistance is nearly equal to what? The smaller resistance. That is what I did here. Okay. So what is omega P? Approximately equal to what? 1 by square root LS CS, because C equivalent is nearly equal to what? CS. But will it be CS really? No, right? I mean, it will be slightly less than CS. Yes or no? Because CS times CP upon CS plus CP, it will be less than both CS and CP, but it will be close to what? CS, which means it is slightly less than CS. Okay. So I can write this as some CS minus delta. Correct, CS minus delta, just to indicate the fact that the point that, you know, it is slightly smaller than CS. Okay. So what is your omega S? The series resonance frequency, it is 1 by square root LS CS. What is the parallel resonance frequency? 1 by square root LS times something that is close to CS but slightly smaller than CS. Okay. So which resonance frequency will be bigger? Because for omega P, denominator is what? Slightly smaller. Omega P will be slightly bigger than omega S. Okay. So this implies omega P slightly bigger than omega S. Okay, so first you'll have series resonance frequency. Immediately after that, you'll have parallel resonance frequency. What is the impedance of the crystal at series resonance frequency? 0, because at LS and CS series combination will act like a short circuit. What is the equivalent impedance of the crystal at parallel resonance? It will tend to infinity. Okay, because this denominator will become 0 at this frequency, impedance will tend toward infinity. Okay, so what is the answer that we got? Omega P slightly bigger than omega S. Okay, so omega S is very close to but greater than omega P. No, omega S is very close to but less than omega P. So option D is the correct option. Okay. Moving on to the next question, the value of Z, that is what this impedance in the figure which is most appropriate to cause parallel resonance at 500 Hz. Okay, so look at this LC combination. I mean, it has to be what, a capacitor, no doubt about it. L and C in parallel, only then you'll have the parallel resonance. In fact, what is the parallel resonance frequency? It is 1 by root LC, and omega naught is what? Same as 2 pi f naught. So this 500 Hz, it is what? F naught. Okay, so in place of f naught, if you write 500, 2 pi into 500 is what? Like 1000 pi. Now if you square on both the sides, 1 by LC is equal to what? 10 power 6 pi square, correct? And then C is nothing but 1 by L into 10 power 6 into pi square. Alright, 1 by 10 power 6, you will get your microfarad thing. Okay, because all options have got microfarad. Now, what is the value of L? It is 2. And pi square is what? Nearly 10. Okay, 3.14 into 3.14, which is nearly 10. So, if pi square is 10 and L is what? 2, are you not having 1 by 20? 1 by 20 is what? 0.05 into 10 power minus 6, which is 0.05 microfarad, and that is what option D. Okay. Look at the next question. In a linear two-port network, okay, when 10 volts is applied to port 1, a current of 4 amperes flows through port 2 when it is short circuited. So there is a two-port network. Across port 1 you connect a voltage source of value 10 volts, and across port 2 you have a short circuit, and the current that flows in that short circuit is what? 4 amperes. Okay, fine. When 5 volts is applied to port 1, a current of 1.25 amps flows through a 1 ohm resistor, again connected across port 2. So in the first case, across port 1 you connect 10 volts, and across port 2 you have a short circuit. In the second case, across port 1 you connect 5 volt source, and across port 2 you have a 1 ohm resistor, not a short circuit, and the current through that 1 ohm resistor is how much? 1.25 amps. And then when 3 volts is applied to port 1, meaning in the third case the voltage source connected across port 1 is what? A 3 volt source. The current through a 2 ohm resistor connected across port 2. Okay, so if I have to write, or if I have to draw the network for the 3 cases, it would be something like this. So in the first case you have this 2-port network. Across the port 1 you connect 10 volt source, and across port 2 you have a short circuit, and the current in the short circuit is what? 4 amps. This is like case 1. And what is case 2? Case 2, across port 1 they are going to connect a 5 volt source, and across port 2 they are going to connect a 1 ohm resistor, and this time the current through the 1 ohm resistor is what, 1.25 amps. Okay, and then in case 3, across port 1 they are connecting what, a 3 volt source, and across port 2 they are connecting a 2 ohm resistor, and they are asking how much current will flow through this 2 ohm resistor. Okay, and the key word here is what, linear. So whatever 2 port network is there, it is a linear 2 port network. Okay, so we will attack this problem with the help of Thevenin's theorem. Okay, with the help of Thevenin's theorem. See, this is what the 2 port network, and across port 2 you have what, a short circuit, and the current in the short circuit is what, 4 amps. I am talking about case 1. Okay, when 10 volts is applied to port 1, a current of 4 amps flows through port 2 when it is short circuited. So across port 1, what is connected, a 10 volt source is connected. Okay, so the point is this, can't you think of the yellow color box as a linear 1 port network? Yes or no? So the yellow color box, the white color box is what, a linear 2 port network, but the yellow color box clearly is what, a linear 1 port network. These two terminals will form that single port. Okay, and you know, any linear 1 port network, can it not be replaced with its Thevenin equivalent, and it won't affect the external voltages and currents. So when you replace this with its Thevenin equivalent, I mean the yellow box, okay, the Thevenin equivalent will contain what, VTH in series with RTH, and then across this Thevenin equivalent or outside of this network you have a short circuit, and the current in the short circuit is what, 4 amperes. So what is this 4 ampere current? Is it not the loop current, which means VTH by RTH? So this 4 amps is nothing but VTH by RTH. So which means VTH is equal to what, 4 RTH. Yes or no? VTH, you can write it as 4 RTH. Okay. Now in the second case, when 5 volts is applied across port 1, a current of 1.25 amps flows through a 1 ohm resistor. Please understand this. So in the second case also, you have the same linear 2 port network, that is white color box is what, same, and this time outside the white color box across port 1, how much voltage they are applying? They are applying 5 volts. Okay, and across port 2, what is connected? They are connecting a 1 ohm resistor, and then they are telling that the current through 1 ohm resistor is what, 1.25 amps. Now also we can think of this blue color box. Please look at this blue color box. Again, it is what, a linear 1 port network, which again can be replaced with its Thevenin equivalent. That Thevenin equivalent will again contain what, VTH in series with RTH. You see, compare the two linear 1 port networks, that is what, this yellow color box and the blue color box. Okay, both are identical except that in the yellow color box the source value is what, 10 volts. In the blue color box the source value is what, 5 volts. Otherwise both the networks are identical. That means RTH will be same for both the networks, but VTH, because it's a linear network, VTH is what, a linear combination of all the various independent sources present in the network. The only independent source in the network is what, the 10 volt source. So for 10 volt source present in the network, the Thevenin voltage, if it is VTH, Then for 5 volt source present in the network, the Thevenin voltage will get scaled down by a factor of 2. Yes or no? For 10 volts, if you are getting some VTH, then for 5 volts, want to get VTH by 2. Yes or no? If the source voltage is reduced by half, every voltage in the network will also get reduced by half, given that that source is the only source present in the circuit. Okay, inside the box, inside this white color box, if you have some additional sources, then this won't be true. Okay, so here the assumption is what? That inside the white color box there are no sources. Okay, but inside the yellow color box there is only one source. So for 10 volts, if you are getting VTH, then for 5 volts want to get VTH by 2. So now also you can draw the Thevenin equivalent, but the Thevenin voltage will be half of the earlier Thevenin voltage. For 10 volts VTH, for 5 volts Thevenin voltage will become half, VTH by 2. But RTH, Thevenin resistance, has nothing to do with the value of the sources present in the network. It only depends on what resistors are present in the network and how they are connected, and that is not changing in the two cases. Okay, so RTH will be same as before. Okay, and then outside of the network, what is connected? A 1 ohm resistor is connected, and then the loop current this time is how much? 1.25 amps. Again, if you apply KVL around the loop, you can tell the loop current to be what? VTH by 2 upon RTH plus 1. Okay, so you can write, 1 second, VTH by 2 upon RTH plus 1 equal to what? 1.25. But then VTH is equal to what? 4 RTH. So in place of VTH, if you write 4 RTH, then 4 RTH by 2 is what? 2 RTH. So this equation will become what? 2 RTH equal to 1.25 RTH plus 1.25. Okay, 2 RTH minus 1.25 RTH is what? 0.75 RTH. Okay, let me write it. 0.75 RTH equal to what? 1.25. So what is the value of RTH? It is 1.25 by 0.75 or 125 by 75, which is 5 by 3. So the Thevenin resistance is what? 5 by 3 ohms. Thevenin resistance is what? 5 by 3 ohms. From here you can also calculate or find the value of Thevenin voltage. Again, use this relation. VTH is equal to what? 4 times RTH. 4 times 5 by 3 is what? 20 by 3. That's all. So these are the values of VTH and RTH. Okay. Now, what is the actual question? When 3 volts is applied to port 1, the current through a 2 ohm resistor connected across port 2. Once again, you visualize the entire network. Again, you have the original linear 2-port network, which is this white color box. And then what are they doing? Across port 1, they are connecting what? A 3 volt source. And across port 2, they are connecting what? A 2 ohm resistor, and they are asking what is this current through 2 ohm. Once again, what is the 2-port network? You can think of the same thing. Okay, so again, this 2-port network, you replace it with its Thevenin equivalent. But what about the Thevenin voltage? So if you recall, or if you go back, for 10 volt the Thevenin voltage is what? VTH. For 5 volt it is what? VTH by 2. Okay, so for 3 volt, what is the VTH going to be? Look at this ratio and proportion. Okay, for 10 volts, if the Thevenin voltage is what? VTH. For 3 volts, the Thevenin voltage will be what? 3 by 10 times VTH. Already we know VTH is what? 20 by 3. So 3 by 10 into 20 by 3. 3 will get cancelled. So now the new Thevenin voltage is what? 2 volts. Okay. So directly I'll put a voltage source of value 2 volts. In series with that, you'll have RTH. What is our RTH? 5 by 3 ohms. Yes, 5 by 3 ohms. And again, across this, we are connecting what? A resistance of value 2 ohms. Let's say the current is what? I. So what is I? 2 volts divided by 5 by 3 plus 2, which is the net resistance in the loop. So what is the LCM for the denominator? It is 3. 5 plus 3 times 2 is what? 6. 6 plus 5, 11. So is it not 6 by 11? And what is 6 by 11? 0.5 and then 4. The value of the current is what? 0.54 amperes. Okay. Let's go back and check the option. So the correct option is what? Option C. 0.54 amperes. Okay. Alright, let's discuss the questions from analog circuits. The input impedance and the output impedance of an ideal transconductance amplifier are. 4 options are given. In fact, for transconductance amplifier, the input, it is what? Voltage, and the output, it is what? Current. So whenever the input is voltage, the input port will behave like voltmeter, and ideally voltmeter should behave like an open circuit, which means the input impedance or the input resistance should ideally be infinite. Okay. And if the output is current, then the output port will behave like a current source. Okay. Output port will behave like a current source. And for a current source, there will be this internal resistance Rp connected in parallel, which also must be ideally infinity. So even for current source, even the output resistance ideally must be what? Infinite. So both Z in and Z out must be infinity, and that is what option A. Well, if you want, I can further tell you what are the ideal input and output impedances of the 4 different types of amplifiers that we have. So what are the 4 amplifiers that we have? One is what? Voltage amplifier. Then we have what? The current amplifier. Then we have what? The transconductance amplifier. And finally we have the trans resistance amplifier. Okay. So if we try to make some kind of a table. Now for the voltage amplifier, the input is what? Voltage. Okay. So input, it is what? Voltage. So the input port will behave like a voltmeter, and voltmeter ideally should behave like an open circuit. That means the input resistance should also be infinite. Okay. And then for the voltage amplifier, the output is also what? Voltage, which means the output port will behave like a voltage source. And for a voltage source, that internal resistance Rs ideally must be 0, which means R out should also be 0. In the same way, we can write it down for the remaining 3 amplifiers. Current amplifier, input is what? Current. So input port will behave like an ammeter. Ammeter should ideally behave like a short circuit. Short circuit means it should have 0 resistance, which means Rin must be 0 ideally. And for a current amplifier, output will be what? Current. which means the output port behaves like a current source, and current source will have internal resistance Rp, which must be ideally infinity. Okay, so R out for a current amplifier ideally must be infinity. And then when it comes to transconductance amplifier, the input is what? Voltage. Again, it means the input port will behave like a voltmeter, which ideally must be open. So Rin ideally must be infinite. In fact, in the question, whatever amplifier they have asked about is what? The transconductance amplifier. And for the transconductance amplifier, output is what? Current, which means the output port will behave like current source. Current source will have Rp, which ideally must be infinity. And finally, we have the trans resistance amplifier, for which input is what? Current, which means the input port will behave like an ammeter, and ammeter should ideally behave like a short circuit. That means Rin ideally must be 0. And for a trans resistance amplifier, output is what? Voltage. So the output port will behave like a voltage source, and voltage source will have Rs, which ideally must be 0. That's all. These are the ideal Rin and Rout values of all the 4 types of amplifiers. Okay.
Okay, students, so let us continue the discussion on the AP Transco 2019 complete question paper discussion along with the solution. This is Rakesh Salraj and I am going to continue the discussions on the questions of control systems. There were total 8 questions found out of 100. I mean out of 70 technical, 30 anyways is aptitude, that also we shall discuss. Okay, the questions were mostly easy, direct or formula level. There is not a question which you have to spend a lot of time on thinking about this. Okay, let's start looking into the question one by one. This is a direct statement based question. Okay, an open loop system is converted to closed loop using negative feedback, and the feedback path has unity gain. Okay, so unity negative feedback has been taken as compared to open loop, the closed loop system. The basic comparison, like the very beginning things that you study in control system, the basic comparison between open loop, closed loop, the overall gain is rather decreased. Okay, not increased. Okay, option number B, bandwidth is also increased, not reduced. This is reverse gaming. Because why? Because actually time constant of the system decreases. Okay, so rise time decreases and hence bandwidth decreases, because rise time and bandwidth are inversely related. So bandwidth increases. Okay, effect of parameter variation, sensitivity is reduced. Okay, yes. Okay, basically this you study in the important topic of sensitivity. Sensitivity of the system is, for closed loop system, is reduced actually. Okay, disturbance rejection capacity. Distraction rejection capacity means noise basically. Okay, so noise. Noise handling capacity is actually increased. Okay, disturbance means noise. Okay, so noise rejection capability is actually increased. It's better in terms of noise closed loop system. So D also wrong. The only appropriate option is C. Next question, basic block diagram question. For the system shown in the block diagram, what is the transfer function C by R? Okay, so what is there? First solve for the inner loop. Okay, let me start solving here. First you solve for the gain of this inner loop. Okay, so what is the gain of this inner loop? Okay, G upon 1 plus GH. Okay, negative feedback is there. A feedback gain, forward gain, everything is given. So 1 upon S plus 1 divided by 1 plus 1 by S plus 1 into the feedback gain, which is S, multiplying by S plus 1, you will get 1 upon S plus 1 plus S, or simplifying it, this is S square plus S plus S. Okay, so total S square plus 2S in the denominator. Okay, now when you talk about the overall system, okay, this is going to become the forward path gain, and then final feedback is unity. I mean the net block diagram, this is going to be G. Now let's say whatever the gain now obtained, that is G. Okay. This is what is the final transfer function. So let me solve the final transfer function here. C by R. The final transfer function here, C by R, will be now G upon 1 plus G. Unity feedback is there. So substituting the data. Okay, 1 upon S square plus 2S whole divided by 1 plus 1 upon S square plus 2S. So multiplying by S square plus 2S, so 1 upon S square plus 2S plus 1.
1 upon s square plus 2s plus 1. That's the simple answer. Okay, that is the option number D. That is what is the option number D here. Okay. Then what is the next question? Number 3rd. A unity feedback system has the following unit impulse response. Okay, the unit impulse response is given, and we know that impulse response Laplace transform is the transfer function. Okay, when you take the Laplace transform, it will be equal to the transfer function. Okay, so can I find out the transfer function of the system? Let us write down the transfer function of the system. Okay, as now basic Laplace formula, t e power minus t, t e power minus at, 1 upon s plus a whole square. So here it is minus, already written, 1 upon s plus 1 whole square plus 2 e power minus t Laplace 1 upon s plus 1, simple. Okay, so you can simplify this by taking the whole denominator as s plus 1 square, then this is minus 1, and here I have to write twice of s plus 1. So 2s plus 2 minus 1. This is 2s plus 1 upon s plus 1 whole square. This is the complete transfer function. The question is open loop transfer function of the system, and unity feedback is there. Okay, so let's go here and start solving it. This is the transfer function. Suppose t, for unity feedback it is g upon 1 plus g. Unity feedback is there, na? Okay, so from here you have to get the value of g. So dear, when you simplify from here, you will write down always g equal to t upon 1 minus t. When you rearrange and write down, you will get g equal to t divided by 1 minus t. What is the t? The overall transfer function obtained as 2s plus 1 upon s plus 1 whole square divided by 1 minus 2s plus 1 upon s plus 1 whole square. Multiplying throughout by s plus 1 whole square, so 2s plus 1 divided by the s plus 1 whole square minus of 2s plus 1. Okay, so this is 2s plus 1 divided by s square. Plus 2s plus 1 will get cancelled here. So 2s plus 1 is divided by s square. Okay, 2s plus 1 is divided by s square. 2s plus 1 is divided by s square. Okay, that is the answer. Okay, so 2s plus 1 by s square, option number A. Here it is, 2s plus 1 by s square. Next one. Yeah, a unity feedback system has gs equal to k by s plus 1. The steady state error in the output response for unit step input is how much? Okay, simple question. Now see, unity feedback system is mentioned, so we can define the type of the system. Direct question on steady state error. Okay, gs, how many poles at origin? Okay, divided by s power 1, 1 pole at origin. So gs given is a type representing a type 1 system. Okay, now whenever it is type 1, what is the steady state error for step? You should know it's 0. Answer is simply 0. Okay, whenever it is type 1, what is the steady state error? ESS for step input? 0, because for type 1 finite error will come for ramp input given by 1 upon kV, 1 upon velocity error coefficient, and for parabolic input, these are the 3 common input for which you must know, and for parabolic it will be infinity. It will be infinity. Okay, for ramp if they ask, the answer is 1 by kV. What is kV? kV is given by limit s tending to 0 s into gs. Okay, so when you substitute s into gs and put s tending to 0, then you will get k. Then the answer will be 1 by k if the question was for ramp input. Okay, so this will be the answer. Okay, let me just solve it. Just additionally I am solving, although question is over, answer is 0. Okay, limit s tending to 0, s into gs. gs is k by s, s plus 1. S cancelled, and then when you put s tending to 0, you get k. And error is 1 upon k. Okay, so I can say the correct answer will be D if the question was steady state error for unit ramp. Okay, if the question was steady state error for unit parabolic, then the answer will be A. Correct, my dear? Okay, next question. The open loop transfer function of a unity feedback system is given to you. Gs equal to k, s plus 1 upon s, s minus 1, s plus 6. Okay, the system is unstable. Okay, unstable for what range of k? Okay, let me first write down the characteristic equation here. What is the characteristic equation? 1 plus gs hs. Gs is given, hs unity feedback, so hs is anyways 1. Okay, so solving this, I'll get 1 plus k s plus 1 upon s, s minus 1, s plus 6 equal to 0. Or solving it further, s cube, multiplying here, 6 minus 1 will be 5, so plus 5 s square then minus of 6s, and then here opening the bracket here plus ks plus k equal to 0. Or let me rewrite the equation here. The final characteristic equation looks like s cube plus of 5s square, then minus 6s plus ks. So that is k minus 6 into s, and last term is k plus k equal to 0. For stability or instability, feeding quickly to the Raoult array or cubic equation shortcut also you can use BC minus AD. Okay, first let me solve it by the Raoult array. So 1 and k minus 6. Okay, and then here I get 5 and k, alternate terms array, and then s power 1 term. 5 into k minus 6 minus k. So 5k minus k, 4k, and minus 30. Divide by 5, last element anyway 0, s power 0 row, suppose this is x, x into k minus 0, so x into k divided by x, k 0. Now the system will be unstable. Unstable means RHP roots, means sign change will come. Okay, means sign change will come. Okay, right now the question is for instability. That means RHP root, and RHP roots are seen in case of sign changes in the first column. Sign changes in the first column. Now this is plus plus, so sign change can happen here or it may happen here. Okay, so that means there are the two possibilities. Okay, 4k minus 30, this parameter should be negative. This will give you k less than 7.5. Okay, or k must be negative. This last term, k must be negative. Okay, so dear, whether you take k, now whether you want to combine them, k less than 7.5 or k less than 0. So k less than 7.5, because if any one sign change will occur, na? Okay, any one sign change will occur. Okay, so the answer will be negative. The answer will be RHP roots or unstable system. So k less than 7.5. K less than 7.5 is the answer. Okay, or what else I am telling you, or since this is cubic equation shortcut, okay, for unstable system is BC minus AD negative, where I call this coefficient as A, B, C, D. Okay, so BC means 5 into k minus 6 and minus AD, so minus k must be negative. You simply have from here also you are going to get k less than 7.5. So anyways, answer is k less than 7.5. Okay, see, the only option that you can match here is C. Okay, so maybe they have assumed k positive. So what is the range? Okay, considering k positive, what is the range? Okay, so then you can say 0 to 7.5. Okay, 0 to 7.5. Although k being greater than 0 is not compulsory here, but maybe they have normally, like we assume, the gain k is positive. Okay, while drawing the root locus diagrams and all. Okay, right. So option number C is what I will consider here. The open loop transfer function of a system is given to you. GSHS equal to 16, s plus 1 upon s, s plus 2, s plus 4. The centroid and angle of asymptotes. Simple question. Okay, the centroid and angle of asymptotes. Okay, what is the formula for centroid? Let me write down the poles and zeros. Okay, what are the open loop poles? S equal to 0, minus 2, minus 4, because this is the open loop transfer function given. Na? Okay, what are the open loop zeros? The open loop zeros, from numerator I get only minus 1. So centroid, what is the formula for centroid? Centroid is given by the formula x summation poles minus summation zeros divided by p minus z. What is p? The number of open loop poles, okay, which is 3 here. Z is the number of open loop zeros, which is 1 here. Okay, summation of pole means summation of the pole location. So 0, minus 2, minus 4. Minus summation of 0. 0 is at minus 1. Divided by p minus z, that is 3 minus 1. So this is how much? Minus 6 plus 1. Minus 5 by 2. Minus of 2.5. Minus of 2.5. And then the angle of asymptotes. The angle of asymptotes is given by the formula odd multiple of 180 degree by n. Okay, what is n? N equal to p minus z, which is 2. Okay, n is the number of asymptotes. N is the number of asymptotes. Okay, so this here becomes 2k plus 1, okay, into 180 degree divided by 2. Okay, so this becomes 90. Okay, 2k plus 1 into 90. So what are the odd multiples of 90? Okay, the odd multiples of 90 are 90 and then 90 into 3, only odd multiples, so 270. Okay, how many theta? Only 2 theta. One angle for every asymptote. So 2 asymptotes are there, 2 angles are sufficient, 90 and 270. Option number C, centroid minus 2.5 and angle is 90 and 270. Okay, direct question on the asymptotes, basic calculation. Okay, so option number C. Okay, let's go to the next one. A system has damping ratio, that is zeta 0.4. The frequency response of the system exhibits a peak resonance. Okay, resonant. This is a question on resonant peak. Okay, MR. Okay, given by the formula. Okay, I write MR given by the formula 1 upon sine 2 phi. Okay, or we can write this as 1 upon 2 sine phi cos phi, where zeta is known as cos phi and zeta is 0.4. So what is sine phi? Let's write down the sine phi. Na? What is going to be sine phi? Sine theta is under root of 1 minus cos square theta, because of cos square theta plus sine square theta 1. So 1 under root of 1 minus cos square theta, 0.4 square, 0.16. So it is under root of 0.84. Without calculator you have to solve it. So approximately 0.81. Under root of 0.81, 0.9 approx. We'll be able to match the answer, I guess, right? So sine is 0.9, cos is 0.4. Okay, so this becomes 0.36 into 2, 1 upon 0.72. Okay, so now see, it is definitely not 2. Okay, and it is not more than 2 also. Definitely 1 point something. Okay, that too 1.36. It's not more than 1.5. It's not 1.5 times. 1.5 times will be 1.18 if you cancel. Yeah, correct. So approximately 1.36. I will mark it as approximately 1.36. So we are able to, options are given so that you are able to mark your answers. Not a big deal there. Okay. Okay. Next question. Right. A lead compensator GCS equal to 1 plus 0.2s upon 1 plus 0.04s can provide maximum phase shift of. Okay, can provide a maximum phase shift of. See, normally you can compare this transfer function GCS as 1 plus 0.12s divided by 1 plus 0.04s can be compared as 1 plus st divided by 1 plus s alpha t. 1 plus st divided by 1 plus s alpha t. So that you can compare and say that the t 0.12 and the alpha factor will be, how much alpha factor will be? Alpha into t 0.04. Alpha into t is 0.04. So alpha equal to 0.04 divided by t, which is 0.12. So alpha is 1 by 3. Okay, so maximum phase shift. Okay, the maximum phase shift, which we call it as phi m, okay, is given by the formula. The maximum phase shift is given by the formula sine inverse of 1 minus alpha upon 1 plus alpha. This occurs at what frequency? Okay, at omega m. Okay, at omega m, given by the formula 1 by t root alpha. Okay, so right now the question is only phi m. Sine inverse of, okay, how much? Okay, sine inverse of 1 minus alpha. Alpha was 1 by 3 upon 1 plus alpha. Okay, so this becomes sine inverse of 2 by 3 upon 4 by 3. So this is cancelling as 1 by 2. Sine inverse half, okay, at 30 degree, because sine 30 is half. Sine inverse half is 30 degree. Okay, 30 degree. Option number D. Option number D is what is the correct answer. Okay. Then they can also ask you what is the value, what is the frequency at which the maximum phase shift is provided. Then you can use this formula. Okay, then you can be using this formula if they ask you. Okay, that's it. These were the 8 questions. As I told you, either direct formula based or direct concept based, but no much calculation and rather no much thought is required. You can straightforward go and answer it. Okay, and it's a general fact that, you know, if you study the control system thoroughly, it is usually going to be scoring only for you. It is going to help you boost performance. You can answer most of the questions very easily. Okay, just one question used little bit of calculation, that was this resonant peak question. That also approximations are enough to conclude the answer. It's not very heavy calculation. Okay, yeah, they have tried to cover Rauther-Waite's root locus, the resonant peak, that is one frequency domain parameter, compensator based question, steady state error, and block diagram. They have taken basic block diagram, the basic comparison between open loop and closed loop. So all fundamentals they have covered. Okay, Nyquist and Bode was not there. Okay, but that again can be anytime expected, because that is very important topic from the entire control system theory, or state space analysis also possible. Okay, students, so now let us continue with the discussions on the analytical aptitude questions asked in the AP Transco 2019 paper. Okay, so again the questions will be as per the said B. Okay, and yeah, this is Rakesh Alreja. Let's keep continuing. The number of questions 30. That is fixed, you know, the 100 marks, the 100 questions are split into 30 aptitude and 70 technical. Okay, so we have already been discussing technical questions as well, including all subjects. Okay, so this is 30 out of 100. Let's see, you know, what is the level. It's mostly easier level only. Okay, some reasoning based questions might test your brain. Okay, but not difficult. Okay, so let's get started. This is the first one for you. Okay, there are quant questions as well. Okay, basic numeric reasoning, which you call it as. Two glasses of equal volume are respectively half and 3/4 filled with milk. They are then filled to the brim by adding water. Okay, so what is the original story right now? Original story is two glasses which are of equal volume. Okay, they are respectively half and 3/4 milk filled with the milk. Okay, this is V by 2, and the second one is 3/4 filled with the milk. Okay, and then they are filled to the brim, that is to the top. Okay, by adding water. Okay, so that means how much water will come up here? V by 2 and V by 4. Okay, the contents are then poured into another vessel. What will be the ratio of milk to water in the vessel? Simple question, huh? Ratio of milk to water. Okay, so how much is the milk? Let's just calculate this number. How much is going to be milk? Okay, V by 2 plus 3V by 4. This is nothing but going to be 5V by 4, correct? How much is going to be water? I'll separately here write down here V by 2 and V by 4. V by 2 and V by 4, and that is nothing but 3V by 4. Okay, so what is the ratio? Okay, the clear ratio is 5:3. Okay, because you have the ratio 5V by 4 divided by 3V by 4. So after cancellation, only 5/3. Option number D, right? Simple one it is. Let's go to the next question here. Okay, so what is there in the next question? In a college, the ratio of number of arts graduate to science graduate is 3:2. If 20% arts graduate and 25% science graduate qualify for IAS, okay, the percentage of non-qualifiers, okay, the total percentage of non-qualifiers, okay, that is what they are asking. To see, in a college, the number of, the ratio of numbers of arts and graduates. So what can I say? The ratio is 3:2. So how much will be arts graduate? You can take 3K. Whenever the quantities are in the ratio 3:2, you can take the quantity as 3K and 2K, of course, na? Okay, and you can take the science graduates to be 2K. Okay, so this is what is 3K and 2K. Now, 20% arts graduate qualify. Okay, so how many non-qualifiers? Okay, let me directly write the non-qualifiers. Okay, 80%, 20% arts graduate qualify. No, so 80% don't qualify. How many are the arts graduate? 3K. 80% of 3K. Then 25% science graduate qualify. So how many do not qualify? 75% do not qualify. So plus 75% of 2K is divided by the total number of students become 5K. If I take 3 and 2 addle, and for percentage, just multiply this by 100. So how much is the ratio we are going to get? 80%. That is 0.8 of 3K. Okay, that is 2.4K. Okay, and then 75 of 0.75 into 2 will be 1.5K. Okay, simple calculation. Okay, divide by 5K. Anyways, K not required. K will cancel. It's going to be how much? 3.9 by 5 or 78 by 10. So yeah, 78%. 78%, option number C it has to be. Done? Option number C. Okay, let's go to the next question then. Here it is. Okay, in a rare coin collection, okay, so see, let me tell you, like, you know, questions might be randomly coming up here. See, first one was 78, because the actual question number in the paper is 71 to 100, but I have, picked up, like, let's say first basic quant questions and then go to puzzle based logical reasoning question like that. Now, like, in a rare coin collection, there is one gold coin for every 3 non-gold coins. Okay, there is one gold coin for every 3 non-gold coins. So what is the ratio of gold to non-gold? Okay, 1 gold for 3 non-gold coins. So 1 is to 3. Okay, now 10 more gold coins are added to the collection. 10 more gold coins are added to the collection, and the ratio of gold to non-gold will be 1:2. Okay, gold to non-gold ratio will be 1:2. Okay, so after 10 more gold coins are added, so how many gold coins are there initially? 1:3 ratio, na? So that means, okay, that means you can say gold coins are K, so non-gold coins will become 3K. Okay, now to this K I add 10 more. 10 more gold coins are added. Okay, and then the ratio of gold to non-gold, okay, will become 1:2. Okay, I don't add anything to non-gold. Okay, so k plus 10 divided by 3k, non-gold remains same, and this ratio is given as 1:2. So first we can get the value of k from here. How much? Simplifying, 2k plus 20, this is equal to 3k. So the k is equal to the 20. Okay, the k is equal to the 20, number 1 point. Okay, based on the information, the total number of coins in the collection now becomes, okay, total number of coins in the collection now. Okay, how much is total? K plus 3k, 4k plus 10, because they are asking now. Okay, how much is the collection now? Okay, so now I'll write here once again 4k plus 10. So since k equal to 20, 4k is 80 plus 10, 90. So I would say the answer is 90, option number A. Okay, option number A it is. Okay, next one. Two persons A and B are running on a circular track. Okay, at the start B is ahead of A and their positions make an angle of 45 degree at the center of the circle. Okay, so let us make this initial picture. Okay, at the start B is ahead of A. Okay, and they are running on a circular track. So circular track you can take any direction. They are running clockwise or anti-clockwise. Okay, of course both are running on the same direction. Okay, B is ahead of it and their positions make an angle of 45 degree at the center. Okay, let's take a circle here first of all. Okay, let's say this is the circle and let's assume that the persons are running in the clockwise direction. Okay, I'll assume that they are running in the clockwise direction. Okay, let's say this is A and B is ahead of A and at an angle of 45 degree. Okay, this is center. Suppose this is B and this angle initially between them is 45 degree. Clear everybody? Okay, now when A reaches the point diametrically opposite, okay, so what is the diametrically opposite point? This one. Okay, take the diameter. Okay, so now this is going to be the new position for A. Okay, when he reaches diametrically opposite point, he is going to meet B. Okay, so this is where they are going to meet. Now, what is the meaning of meeting? Okay, both will be at this position at the same time. Two persons at the same position at same time, then they meet. Na? That is what it is a concept. Okay, what is the ratio of the speeds? Okay, so from A to meeting point, how much is the distance? And from B to meeting point, how much is the distance? Okay, so see, simple, distance is speed into time. Let's use this simple point. Okay, so what is the distance traveled by A? Okay, let's write down the distance in terms of degree. Diametrically opposite point, semicircle, 180 degree. A travels 180 degree with the speed of A. Okay, with the speed of A and in some time t. Okay, B travels, how much is this remaining angle? How much is this remaining angle? This is 135, correct? This is 135. Okay, so B has traveled 135 degree with its speed SB and in the same time. Because they have to be here at the same time, then only they meet. So time is common. Okay, so what is the ratio of the speed of B and A? Simple question, na? Okay, so what is the SB by SA from here? SB by SA is given by 135 is divided by 180 and that is nothing but cancel by 45, 3 by 4. The answer is 3 by 4, option number D. Option number D. Okay dear. Next question. If x and y are two natural numbers such that x is between -3 and -1, y is between -2 and 1, then x square minus y cube. Now see, there is a small correction in this language. I mean, if you take x between -3 and -1, it turns out to be only -2, but that will not give you the answer. X between -3 and -1, they have included -3 and -1. That means, what I mean here is the value of x to be taken is -3, -2, -1, including the boundary points. Okay, y takes what value? Okay, y takes the value between -2 and -1. Again, take the boundary points included, -2, -1, 0 and 1. This is the last value. Then x square minus y cube. To make it simple, nothing. I'll first write down x square values for you. How much is x square value? Okay, if you take the square, it becomes 9, 4, 1. And if you take the cube, y cube, x square minus y cube is the question. Huh? If you take the cube, how much is going to be the cube value? Y cube value. So -2 cube is -8. Okay, then -1 cube is -1. 0 cube is 0, 1 cube is 1. This is what it is. Now, x square minus y cube is which of the following? I mean, the range we have to calculate. Okay, the range we have to calculate. So, see, if you calculate the range, then what is going to be the answer here? Okay, the minimum value, the minimum possibility clear is 1 minus 1, 0. Okay, the minimum thing, x square minus y cube, very clear, na? The minimum possibility that I see is 1 minus 1, 0. Okay, 1 minus 1, 0. Minimum value 1 minus 1, 0. Maximum value? 9 minus minus 8. Okay, when you're subtracting minus becomes, so this becomes 9 plus 8 then. 9 minus of minus 8. So total answer 17. Okay, so 0 to 17, option number B I will take mark. Option number B I will take mark, okay. Alright, then let's go to the next question. Okay, so usually I told you simple achievable questions, okay. The idea is that in the exam time also your target is like 100 questions and 120 minutes. That was the last pattern. Let's see how this year the pattern they are going to give. But okay, 100 questions, 120 mark. Mostly this is what is expected, in the AE exam. So almost you have to target per minute one question, and they are achievable. Okay, of course you have to be in the flow and practice. That's why we just suggest you to keep on practicing aptitude daily, 30-40 minutes. You just in the practice you'll be able to solve these questions easily. If you're not into practice, you might take time. They are still solvable. There is no great science in any of the question here. Okay, now what is there? 3 bus tickets from city X to Y and 2 tickets from city X to Z cost rupees 61. Okay, so let's say from city X to Y the price is rupees A. Okay, price is rupees A, and 2 tickets from city X to Z. Suppose the price from city X to Z is something rupees B. Okay, so what is the first data? 3 from this, that means 3A. I'll write down here, and 2 bus tickets from X to Z, that is 2B. 3A plus 2B, this is 61. Okay, now what is next given? But 2 tickets from X to Y, same, 2 tickets from X to Y, that means 2A, and 5 tickets from X to Z, 5B. This cost how much? 81. What are the fares? Okay, for cities Y and Z from X, that means X to Y and X to Z. Okay, X to Y is A and X to Z is B. That means I want the value of A and B. So 2 variable 2 equation, just have to solve it quickly. Okay, so we can substitute, say, let's replace B na. Okay, 2A, or you can solve by any methods, what you feel comfortable. Okay, I'm replacing B. 61 minus 3A divided by 2. This is going to be 81. I shall multiply by 2 throughout. Okay, so I'll get quickly 4A plus 5 into 61 should be 305 minus 5 into 3 minus 15A is equal to 2 into 81, 162. Okay, so solving this, I'm getting 11A is equal to how much? 305 minus 162, so 143. Okay, that is 13 into 11. The value of A is 13, obtained. Okay, so 13 comma option number, then what is the value of B? Okay, B also I verify. So B, again the same parameter, 61 minus 3A, 3 into 13 divide by 2. Okay, so 39, the gap of 22, 22 by 2, 11. Okay, so 13 and 11, option number D. 13 and 11, option number D it is. Got it? Option number B. Yeah. Let's go to the next question then. Okay, let's go ahead to the next question. Okay. If certain amount of money becomes rupees 2,500 in a span of 5 years and 3,000 in a span of 7 years at simple interest, okay, simple question on simple interest, then the principal amount is how much? Then the principal amount is how much? Okay, let's do it. What is there? Okay, so principal amount is how much? Okay, so simple interest. What is the simple interest formula? Simple interest is given by PRT divided by 100. P is the principal, R is the rate of interest, T is the tenure, time. Okay, now amount, the certain amount becomes, okay, so what is the amount in case of simple interest? Amount is given by principal plus simple interest, that is P, that can be taken common, then 1 plus RT by 100. 1 plus RT by 100. This is what is going to be the value. Okay, so let me write down the data here. Okay, so what is the first amount? It becomes, I'm using this formula here, P into 1 plus RT by 100. Okay, so what is the first story? The amount becomes 2,500 in 5 years. Okay, so 1 plus 5R by 100. And the second story is the same amount, the same value becomes 3,000 in 7 years. Of course, it will grow with time. Question is, what is the principal amount? We need to find the value of P. So what we can do is, okay, first of all, if I take the ratio, okay, 2 by 1, 3000 by 2500, P will get cancelled, 1 plus 7R by 100. Okay, so I am doing 2 by 1, okay. Okay, and first let's simplify this calculation. So 3000 by 2500 is 6 by 5. Now this is how much when you divide here, 1 plus 7R by 100 divided by 1 plus 5R by 100. Okay, so let me solve this here. How much do I get? 6 plus 6 into 5, 30R by 100 is equal to multiplying 5 there, and 5 into 7, 35R by 100. Okay, so I have 5r by 100 is 1. Okay, so value of r obtained first of all, 100 by 5. The rate of interest is 20%. Okay, then use any one equation. Okay, let me use this equation. What is there? 2500 is equal to principal into 1 plus 5r. 5 into r will be 100. Okay, divided by 100. Okay, so the value of p is then, okay, this becomes 2. So value of p is 2500. You divide by 2, it becomes 1250. Okay, it becomes 1250. That should be the answer. Okay, how much it is? 1250. Option number C ready for you. Okay, 1250. Then next question. A train travels at a certain speed for a distance of 63 km and then travels distance of 73 km at an average of 6 km per hour more than the original speed. If it takes 3 hours to complete the journey, what is the original speed of train in kilometer per hour? Okay, so let's put down the given data into equation. A train travels at a certain average speed for a distance. Okay, so again, use distance as speed into time. And what is the first distance? 63 with some speed s. Okay, and taking some time, suppose t1, and then travels a distance of 73. Then it travels a distance of 73 at an average speed of 6 km per hour more than original. So originally I have taken s, so now the speed is s plus 6, and then it takes some time t2 because they have not mentioned that this distance is travelled in equal time. So I will take 2 times t1 and t2. If it takes 3 hours to complete the total journey, so what is this 3 hours? That t1 plus t2 is 3 hours. Okay, what is the original speed? I need to find a value of s. Okay, so we have to solve this equation here. Okay, just only this question I felt little calculative, that too little. Okay, by little manipulation we'll try to solve it up. Okay, so if I add these two, okay, if I simply add these two, what do I get? 60, 130 and 136. 136 is equal to, see, st1, okay, plus here st2. Okay, so s I can take common, S I can take common because I know the value of t1 plus t2. The st1 from here, st2 from here, plus 62. Plus 62. But t1 plus t2 is known to me as 3. So what is the result? 136 equal to 3s plus 62. Okay, so now I need only s value. So we'll replace t2 actually. Okay, let's replace the value of t2 and let's keep solving here. Okay, so 136 is equal to 3s plus how much? Let me write once again. 62. 62. Now what is the value of t2? The value of t2 is 73 by s plus 6. 73 divided by s plus 6. Okay, so now solving this fully, multiplying by s plus 6 throughout, so 136 into s plus 6, okay, should be equal to 3s into s plus 6 plus 6 into 73. How much this becomes? 420, 438. Okay, s plus 6 multiplied throughout. Okay, let's open the bracket. 136s plus 136 into 6. So this should be how much? 13780 plus 816 is equal to 3s square, quadratic equation, plus 18s plus 438. Okay, so arranging the term, 3s square, now 18 minus 136 minus 118s and plus this is going to be how much? If I subtract this one, how much is this value? Rather it will be reverse. Okay, no problem. This value is how much? Okay, and this is 378. Okay, so rather minus, yeah, that's what I'm telling. This will be minus actually, sending everything on the other side. Minus 3, how much I calculated, I forgot. Okay, yeah, 370, again subtracting, yeah, 378, correct, this is what I obtained. Okay, so now you have to solve this one, that's what it is. See, if you try to divide by 3, 118 by 3, okay, approximately let me write s square. Now let me assume it as 117. So when you divide 117 by 3, it will cancel as 39. Okay, 39. Okay, this I have taken approximated as 117 by 3. So I have approximated this by 117, no harm. Okay, and then let me take another value. If you divide this by 3, how much do you get? You actually get 1, 2 and 6. Correct. So only one approximation I think is required. Okay, 117 by 3. So approximately. Okay, now you can see that this is factorizable as s minus 42, s plus 3. See now, 42 minus 42 plus 3 will be minus 39 here. 42 into 3, 126. Okay, so what is the value of the speed? 42 and minus 3. Minus 3 cannot be the answer. So the only answer for the speed is speed 42 km per hour. 42 km per hour. Yeah, here we have in the option as well, 42 kilometer per hour. Option number C is the correct one. Okay, 42 kilometer per hour. That's it. Okay. All right. So the next question then. Yeah, there are 4 hobby clubs in a college. Okay, that is painting, photography, chess, and dancing. The painting group meets every second day. The photography group meets every third day. The chess group meets every fourth day, and the dancing group meets every fifth day. Okay, how many times do all the 5 groups meet on the same day within 240 days? Now, how many times you forget? Okay, all the 5 groups. Okay, all the 5 groups meet. I think there is a typo error or maybe error in the question. I will check later, but it has to be 4 groups. There are 4 groups: painting, photography, chess, and dancing. Okay. Now the painting group meets every second day, the photography every third day, the chess every fourth day, and the dancing every fifth day. Okay, they all meet. Okay, all the meeting. Okay, that means you have to take a number. See, because the what is the first one? Painting. It will meet every second day, like second, fourth, sixth, eighth, etc. Okay, photography every third day. Okay, third, sixth, etc. Okay, that is what is given. Okay, this will meet on every second day, second, fourth, sixth, eighth, etc. Photography every third day. Okay, so 3, 6, 9, etc. So on the 6th day, these two will meet, but I have to find, okay, all the 4 groups meeting the day. Okay, chess people meet on every 4th day. So that is 4, 8, 12. Okay, and then last dancing, the dancing group meets every 5th day. The dancing group meets every 5th day. That is 5, 10, 15, etc. Okay, so they all meet on which day? Okay, on the common multiples of. On the common multiples of the 2, 3, 4, 5. Okay, and the common multiples of this, okay, first let me write down what is the LCM of these numbers. Basic numbers 2, 3, 4, 5. Okay, 2, 3, 6, 4, 5, 20, and the LCM would be 30, no, 60. Okay, 60 is the LCM of them. Finish. Or LCM by any method you can calculate. So what are all the common multiples? 60 is the lowest common multiple, 60. So the 60, then they again meet on the 120th, then 180th, then 240, and then etc. The question is, how many times do all the 4 groups meet, okay, on the same day within 240 days? So in 240 days, 4 times, 4 encounters are there. Option number D. Option number D. Yes, definitely. You can let me know later in the comment box that if there any doubt, okay, I'll reply there, or you can ask me in the Telegram also separately. Okay, this is D is the correct answer. Okay, let's go to the next question then. What is there? Okay. See, a product is given but combining digits, combining some letters. ABC into DEED is ABC, where ABCDE are different digits. All of them are different digits. Okay, which of the following, which are the values of D and E? I want the value of D and E. Okay. Okay. How do you multiply? Let's start the simple pattern of multiplication. What is given? ABC. Let me take the smaller number actually. Let me start here with D, E, E, D multiplied by A, B, C. Okay, so then what is this? C into D, whatever the result is. Then the next will be CE, of course. Next will be again CE, and next will be CD. That is what we do. Okay, then this is going to be BD, then BE, then again BE, and the next is BD. That is how you multiply. Then here AD, then next you have AE, again AE, and last is going to be AD. Okay, now this is CD, this is CE plus BD. Okay, so now see, let me stop here. What is the result given? The result given is ABC. Okay, what is the result given? Is A, B, C, A, B, C. Okay, now that means CD equal to D. Sorry, CD equal to C. CD equal to C. So this hints you that D may be equal to 1. D equal to 1. Okay. Or from here you can see what is our this result. Okay, I'll write down here a little bit more clearly, creating one more space. Keep looking here. Okay, what was this? AD. Okay, and what is AD? AD equal to A. That also hints you D equal to 1. Okay. AD equal to A. So this also hints you that D equal to 1. So D and E were required, D equal to 1. Now dear, if D equal to 1, look into this next calculation. What is expected here? I'll write down separately. What is expected here is CE plus BD, that is equal to B. But what is D? D equal to 1. Okay, so I will say CE plus B equal to B. So B cancel, that means CE equal to 0. That means CE equal to 0. Okay, so now dear, if CE equal to 0, what is the possibility? Okay, we have to see that. Okay, yeah, what is equal to 0? We'll get the idea from here. CE equal to 0, na? It says that C equal to 0 or E equal to 0. Okay, now you see here. Okay, E equal to 0 now. This is BD. Okay, from here also I'll get the same answer. Okay, see what is this? Okay, BD plus AE equal to B. D is anyways 1. Okay, so B plus AE equal to B. Again B cancel, so AE equal to 0. So this again says you that A equal to 0 or E equal to 0. Okay, so that means E equal to 0 is the common solution, because C and A both cannot be 0. All are different digits. All are different digits. Okay, so possibility is E equal to 0. So correct answer is D1 and E0. Correct answer should be D1 and E0. So respectively option number B. Respectively it is option number B. Okay, respectively it is the option number B. Okay, done. Let's go to the next question then. Okay. Ram and Sham, they start from the same point but in opposite directions. After each 1 kilometer, Ram always turns left and Sham always turns right. Okay, Ram always turns left and Sham always turns right. Okay, which of the following statements is correct? Which of the following statements is correct? Okay, let's do this. Okay, so after every 1 kilometer, okay, let's try to create this picture here. Okay, so Ram and Sham start but in opposite direction. Okay, let's say this is where they start from. Okay, okay, let's say this is Ram. This direction is taken by Ram. Okay, and Sham of course will go in opposite direction. After each 1 kilometer, what is happening? Ram turns left. Okay, so after each, suppose this is 1 kilometer complete, Ram will now turn left. Okay, again 1 kilometer complete, again left. Right, like that we will keep tracing. Okay, and then what about Sham? After each 1 kilometer, Sham always turns right. Sham always turns right. Okay, so Sham was traveling here. Okay, let's say this is 1 kilometer complete. Now this is the way Sham is going. So 1 kilometer will be here. Okay, right. Sham will turn right. Okay, and then again this will be the right hand of Sham. Na? Again 1 kilometer. So that means they again meet here. Okay, they again meet here. Okay, and then this story will keep going. Now let's read the correct answer. After both have traveled 2 kilometers, the distance between them is 4. Okay, after both have traveled 2 here and here, the distance between them is only 2, na? The distance between them is this much, that is only 2, 1 plus 1. Okay, okay, so no, this is not correct. Okay, the distance between them is 2 kilometers actually. They meet after each has traveled 3 kilometers. Okay, let us see. They meet after each has traveled 3 kilometers. 1, 2, 3, correct? 1, 2, 3. After each has traveled 3, they meet. Correct answer. Option number B. Finished. But you can verify others as well. What is there? They meet for the first time after each has traveled 4. Wrong only. They go on without ever meeting. Wrong. I have shown you that they meet. Option number B is the only correct answer. Okay, dear? Okay, then I am going to the next question. Okay, now see a basic passage conclusion. Okay, now see just 1 or 2 basic passage based questions were there. Okay, otherwise mostly questions are quant or either logical reasoning, some puzzles or blood relation like that. I will show you those questions as well. Okay, what is there? A successful democracy depends upon the widespread interest and participation in politics, in which voting is an essential part. In which voting is an essential part. Okay, right. Right. Now to deliberately refrain from taking such an interest and from voting is a kind of implied anarchy. Okay, it is to refuse one's political responsibility while enjoying the benefits of a free political society. Okay, this passage relates to. Okay, so clearly this passage is trying to give you the message that a successful democracy depends on the widespread interest and participation of people in politics, in which voting is an essential part. Okay, what many people do, they avoid this responsibility, especially voting, and they want to enjoy the benefits of the society. Okay, this passage relates to, of course, definitely it is more about voting, okay, but right to vote or duty to vote? See, right and duty are two different things. This passage is emphasizing that people must vote, they must take it as a duty to vote. Okay, you have the right, but you have to fulfill it, so that becomes your duty. You have the right to vote, but it is your duty to actually vote when you are eligible to vote as per your age. Okay, so duty to vote is the correct essence. Okay, what is there? Let's not discuss more onto it. Now you go to a movie theater with your family to watch a movie for which you had been waiting for weeks. Okay, this is a passage question, but I felt more of they are trying to check your ethics, rather than English. You go to a movie theater with your family to watch a movie for which you had been waiting for weeks. Okay, a person selling the tickets asks for double the printed price of tickets. Okay, so black marketing is happening. A person who is selling the tickets asks for double the printed price as only few tickets are left. So black marketing. Then what you would do? Okay, then what you would do? Okay, in such cases, okay, you know, in exam especially, you have to answer ethically. Okay, what you actually are going to do, that you decide, but you have to answer it ethically. So you threaten to report the matter to the theater administration unless he gives you the ticket at the regular price. That means you're arguing and you're threatening the ticket seller itself. Second, you go back without watching the movie. Okay, this is very relaxed, you can do. Okay, third, you take the tickets. Okay, you wanted to watch movie for weeks. Okay, whatever, he's asking for double triple, I don't care, I will purchase and I will watch the movie. Okay, that's what my enjoyment is. Okay, not purchase the ticket, okay, and report the matter to the theater manager or administration. So ethically, if I say D is the most correct answer. If you simply go back, okay, then also, okay, you're not arguing, but you're not doing your perfect duty, because somebody in front of you is doing the wrong thing. He's selling the tickets at double the price. Okay, you should not threaten that person. Also, you should also not become like him. Neither you should take it. Otherwise, if you accept the ticket, he will keep doing it. Rather, you should not watch, you should not purchase the ticket and go and report to the manager or administration so that they may take the required measures. Okay, and if the manager agrees with you, he might give you the ticket at the actual cost, what is the printed price. Okay, option number D. Option number D. Okay. Yeah. Next one. In the following question, two statements 1 and 2 are given. There may be cause and effect relationship between the two statements. Okay, there may be cause and effect relationship between the two statements. These two statements, okay, may be the effect of same cause or independent causes, or these statements may be independent causes without having any relationship. Okay, so whether it is cause, whether it is effect, whether they are dependent, independent, that we have to identify. Read both the statements and mark your answer. Okay, what are the statements? Number 1, the life today is fast. Okay, too fast. The life today is fast, too fast. Okay, demanding and full of variety in all aspects. Okay, which at times lead to stressful situations. So life today is fast. In fact, very fast. Okay, very demanding. Okay, you have to be a dynamic person. Okay, and this at times lead to stress among the people. Okay, to compete. Then, statement number 2, number of suicide cases among the teenagers is an increase. Now think whether they are related or not. Okay, number of suicide cases among teenagers is on increase. This is probably, the above one is probably one of the reason, at least one of the reason why, the number of suicide, because the same story with teenagers, everybody, it's a highly competitive, you think about any exam, it's a highly competitive examination, okay, very demanding, and this at times is leading to stressful situations. Okay, and for those people who are not able to, see, I'm telling you, this is one of the reason. Okay, the second big reason for this would be not only the stress of the exam, okay, it's how your family or atmosphere is expecting from you, because competition is there for everybody, but many a times, this word demanding, too fast, okay, the people feel the thing so demanding because of their own, because sometimes because of their parents or their elders or because of their neighbors, that they are feeling more pressure of performance. Okay, but yeah, this is definitely one cause which leads to this effect. Okay, so which answer I will pick up? Yeah, if statement 1 is the cause, statement 2 is its effect. Correct. Okay. This is the effect, okay, and the above one is the cause, the reason, and what happens is the effect, statement number 2. Okay, next one. Okay, simple, what I can say is non-verbal reasoning, a picture-based simple reasoning question. consider the following figure and answer the item that follows. Okay, what is there? Okay, what is there in this question? Okay, see this. What is the minimum number of different colors required to paint the figure given above such that there is a condition? No two adjacent regions have the same color. Okay, and what is the minimum number of different colors you can use? No two adjacent regions will have the same color. Now see, this is alternate, na? Okay, so I'll name the colors as C1, C2, C3. Because this is alternate, you can use C1 and C2, only two colors, okay. Then this can be C1, C2, okay, or rather let me simply code it as 1 and 2. 1, 2, 1, 2, 1, 2, 1, 2. Similarly, here also you see alternate 8 colors are there. 1, 2, 8 blocks are there. 1, 2, 1, 2, 1, 2. Okay, so no two adjacent blocks are having the same color. But here if you use any of the 1 or 2 color here, if you use any of the 1 or 2 color, it is going to be adjacent with the above one, and adjacent box should not be having the same color. So here some third color is required. Here some third color is required. Okay, now here again you cannot use 1 or 2. Here again you cannot use 1 or 2. Okay, so here again the third color can be used. Okay, now you come to the innermost, and innermost any one color out of 1 or 2. 1 or 2, anyone. Okay, 1 or 2, anyone can be used here. Got the idea? 1 or 2, anyone can be used here. Okay, so how many? 3. Minimum 3 colors are required to paint the figure so that no two adjacent blocks, okay, or adjacent regions have the same color. Okay, fundamental logic. How many letters of the English alphabet, okay, capitals, very clearly specified, okay, appear same when looked in the mirror? Okay, that means when looked in the mirror, okay, so whenever an object is looked into a mirror, the image created is like the image created around y-axis. Okay, around y-axis. If this is the mirror, okay, say if this is the mirror, and if you see first the letter B here, suppose I place B here, what is the image of it? Okay, so it's going to be like an image about y-axis, and it looks like this. Reflection about the vertical axis. Okay, does it look same? The question is, which letters appear same when looked in the mirror? Does it look same? No. So basically, which letters? So now you don't take mirror and draw. Okay, basically, if B, you draw central line around B, and if it is symmetric around the central line, central vertical line, then it is going to be symmetric. So see, A is one such case. Okay, when you take a line passing, vertical line passing through center, left and right you see identical. B is not there. C also will not satisfy. What will satisfy? Not E, F, G, H. Rest you also keep trying. Okay, H, I also should satisfy. Okay, left and right identical. I, J, K, L, M. M should come. In the mind itself you can figure out. Okay, N will not satisfy. O, P, Q, R, S, T will satisfy. T, U, V, W, X, Y. Okay, see, around the central vertical line, the left and right identical. Okay, but not Z. Okay, so how many you can count now? 1, 2, 3, and 4, 5, and 6, 7, 8, 9, 10, 11. These are 11. Option number C. These are 11. Okay, basic mirror image question. Okay, next one. Yeah, the letters L, M, N, O, P, Q, R, S, and T in their order are substituted by 9 integers. Okay, 1 to 9. Okay, the 9 integers are 1 to 9, but not in that order. I mean, it's not like 1, 2, 3, 4. Okay, these are the 9 letters, and they will be given the numbers 1 to 9, but not in the same letter order given. Okay, now 4 is assigned to P. Okay, so some hint is given. So what is this? Simply I will write down this data here. This is simple mapping only. L, M, N, O, P, Q, R, S, T, U. These are the 9 letters given. Okay, S, T, sorry. Okay, then P is, 4 is assigned to P. Okay, 4 is assigned to P. That is clearly mentioned to us. The difference between P and T is 5. Okay, P and T is 5. Okay, so the difference is 5 means 4 plus 5, 9. 4 minus 5. Difference could be either side, but 4 minus 5 becomes negative. I only have to use this 1 to 9. So 4 plus 5, 9 is assigned to T. Okay, because difference between P and T is 5. Clear? Then the difference between N and T. So now I know T. N and T difference is 3. Okay, so T is 9. 9 plus 3, 12. Not allowed. 9 minus 3 is 6. Okay, so N should be 6. N should be 6. Okay, I'll write here. This has been taken as 4 plus 5, and then this has been taken as 9 minus 3. Okay, that's it. What is the integer assigned to n? That's the answer. Option number. The integer assigned is 6. That is option number D. Simple question. Huh? Simple question. Okay. What will come in the place of question mark in the following series? In the case of question mark in the following series. Okay. So some numbers, they form a specific series, a basic logical reasoning question, 5, 14, 45, 130. So one hint is, okay, the numbers that are given, okay, they are into 3, closer to into 3, like 5 into 3, 15, not exactly 15. 14 into 3, 44, sorry, 14 into 3, 42, not exactly 42, but closer to it. Similarly, 45 into 3 is 135, so again closer. Okay, so into 3 could be the logic. Okay, so I start with 5, okay, then I have 5 into 3. Minus 1 will give me 14. Okay, then what I have next? 14 into 3, 42. So I have to add 3, then I get the result number 45. What is there next? 45 into 3. Okay, 45 into 3, 135. So this time I have to subtract 5. Okay, so I get 130. Now, what is the desired number? See, the desired number looks like number 130 into 3. Now minus plus, alternate odd numbers are, sorry, consecutive odd numbers are coming. So minus plus, next will be plus. 130 into 3, 390 plus 7, 397. 397 is there in the option also. Let's verify this. Let's still verify. Then the next number in the series should be 1182 by this logic. So 397 into this number multiplied by 3. And now next term is minus. Okay, you multiply and check, you will get 1182. Okay, you will get 1182 because this is 1191 minus 1, 1182. Correct. So option number A. That's it. Option number A, 397 is the correct answer. Okay. Which one set of letters, when sequentially placed on the gaps in the given letter series, shall complete it? Okay, you have to see what comes in the gaps. Okay, so what is there? BMS. Let me write it more in a bigger way. BMS dash TVB dash SUT dash BM dash U dash V BMSUTV. Okay, see, BMS, this gives me the hint. You see here, BMSUTV, BMSUTV. Again, it's a repetition. BMSUTV, BMSUTV. So one particular pattern here, BMSUTV repeats. Okay, and the missing letters are UMVST. UMVST, option number D. UMVST, option number D is done. Okay, UMVST is what is the correct answer. Okay, done. Then let's go to the next question. Okay, BDEH is to FLOX as ACFFG is to. Now, in case of series, especially letters, you can also use the position of the letters. Okay, that's going to make the problem simple. Okay, so how? You see here. Okay, first what is given? B, D, E, H. B, D, E, H. What is the positions? Now, B is the second letter, D is the fourth letter, E is the fifth letter, H is the eighth letter. Okay, is to FLOX. Okay, is to FLOX. This is to FLOX. FLOX. So F is what? Sixth. Okay, L is how much? J, K, L. L is 12th. O is 15th. Okay, X, second last, third last, 24. X, Y, Z. Okay, these are the positions. Now, A, C, F, G is to how much? Okay, what is A, C, F, G? A is first, C is the third, F is how much? F is the fifth, and G is the seventh. Okay, this is what is the combination given to me. Okay, now you see here, what is the pattern here? Okay, this is into 2, or rather, okay, I will map this number here, into 3, again into 3, again into 3, again into 3. Okay, I will write down here what I just told is, okay, all these numbers respectively, okay, 2 into 3, into 3, this also into 3, same into 3, and same here into 3, correct? Okay, So while writing the answer, you have got the logic now. While writing the answer, you have to take this into 3. Okay, you have to take this when you do into 3, 9. Then this is 15 and this is 21. Okay, so what are the letters? Third letter A, B, C. C is the third one. Ninth, I, J. I is the ninth one. Okay, 15th letter will be O and R, S, T, U. Okay. Okay. No. Sorry. Yeah, that is why answer is not matching. Just one correction here. The position of F I have just written wrong. Okay, F is how much? F is 6 actually. Okay, F is 6 actually. So when you multiply this by 3, you get 18th. So O, P, Q, R. This is R and then U. C, I, R, U. There is the option. Option number B. Okay, the position of the letters were important while solving this question. Okay. Alright, next question. Okay, a blood relation question. Okay, always to be solved by family tree. Okay, where family tree, is it important? Blood relation is always a very expected question in many of the exams. Okay, so you can separately also watch the videos on blood relation. Okay, even available on the OHM Institute also. Family tree will always help you. Okay, what do we do in the family tree? Whenever, see, like P is the brother of N. Okay, so brother means male. I'll draw the family tree here only. Okay, P is the brother. Brother means male. Okay, male will be represented by the box. Female will be represented by circle. These are codes. Just to solve the question, we have developed some codes. P is the brother of N. Okay, and brother, siblings are represented by dash symbol. Dash means siblings. Equal to means marriage. Equal to means marriage between the two persons. Down arrow means this is parent to child. Parent to child. These are some codes you should always remember and follow. Okay. Now see, I'll continue here. P is the brother of N. Brother or sister means siblings. Okay. So and P is the brother, so box. Okay. N gender is not known. O is the daughter of N. Daughter. Parent to child. O is the daughter. Daughter means female. So put a circle. O is the daughter of N. That's it. R is the sister of P. Now R I will take here. Sister again means sibling, and R is the sister. Sister means female. Nah. Sister means female, so put a circle. So R is a sister. See, this is used, this is used, this is used. Next, Q is the brother of O. Q is the brother of O. So come to the O level. Okay, Q is the brother of O. Okay, what is there? Q, brother. Brother means male. Okay, so put a box and brother. Brother, sister, they are siblings. Okay, so dash symbol. Okay, then S is the husband of N. S is the husband of N. Okay, husband means male, box, and husband or wife means marriage. So married with N. Now if S is the husband, N becomes wife. So what is the gender of N? Female. Okay, and they are married. So equal to symbol. Clear everybody? Equal to. Now who is the uncle of Q? You see here, who is the uncle of Q? See, O and Q are both the children of N and S. Okay, now P is the brother. Uncle, who is the uncle? Brother of your father or mother. It can be paternal side or it can be maternal side, father side or mother side. But brother of your mother or father, anybody is your uncle. Okay, so P is the uncle because P is the brother of mother of Q. Okay, so who is the uncle of Q? Answer is P. P here is the brother of N. N is what? N is the mother. Okay. So brother of mother or father, anybody, generally we call it as uncle, right? Generally we call that as uncle. Okay? Yeah. So option number A, correct answer is option number A. Done. Next question. See, if you have such a family tree, then anything, any type of question, any relation they can explore, everything you can answer from this family tree. This is what I call it as the family tree. Okay. Basic logical deduction. Syllogism. Okay, the type of the question, syllogism. Okay. Consider the following statement. All artists are whimsical. All artists are whimsical. Now you see. Okay, what we do in such cases is, suppose artists are represented by A and all artists are whimsical. Okay, all of the artists are whimsical. Okay, suppose this is whimsical. So this is artist. Okay, I'll write once again. Or see, suppose this is artist. So all artists are whimsical. All the artists are whimsical. Okay, that means artist will be drawn inside whimsical. So that these can be many artists, but all of the artists are whimsical. Okay, all of the artists are whimsical. Okay, W. Then some artists are drug addicts. Not all, but some of them are drug addicts. Okay, some of them are drug addicts. So let's say this is the circle or this is the set of drug addicts. Okay, some of the artists you see are drug addicts as well. Okay, then third statement, frustrated people are prone to become drug addicts. Now see, frustrated people are prone means likely, not confirm, but there is a set of frustrated people, they are likely to become drug addicts. Okay, so frustrated people are likely to be inside because they are likely to become drug addicts. There can be other people also who become drug addicts, but frustrated people, okay, they are frustrated, they are not able to do something, they are frustrated because of that and they go to drug addiction. Okay, so this can be frustrated people. Okay, but what will I say here is this frustrated people is likely to be inside drug addicts, but not sure. When I say likely means possibility is there, but not sure. But when I say all artists are whimsical, that is confirmation that all of these artists are inside whimsicals. Okay, are inside whimsical. Okay, right. Okay, what is the meaning of this first statement? All artists are whimsical. Suppose if I tell you, all pen. Understand this statement. All pen are stationary. So what is the meaning of this, dear? There are so many stationary items. Okay. There are so many stationary items like pens, pencils, erasers, sharpeners, registers, notepads. There are many things you get on a stationery shop. Okay, pen is one such kind. Okay, but all pens are a type of stationery, na? Okay, these are so many pens. There are pens of many brands, many colors, many variety of pen, but all of the pens are stationary. Okay, what is the reverse of this? If this is a statement, just explaining you one example. Okay, if this is the statement, what is the conclusion you can draw out of here? Okay, that there are so many stationary items. Okay, can I say all stationary are pen? No. Reverse, if you want to see, reverse, you can say that some stationary are pens. There are so many stationary items, I told you, pen, pencils, books, notepads, etc. So some of these stationaries are pen. Okay. So that is what I mean by all, A are B. A inside B. Whenever you read the statement, all A are B. So A is inside B. That is what you have to place down. Okay. So three statements I have placed down. Now from the above three statements, what can be concluded? Concluded means something which is 100% concluded, 100% sure. There should not be maybe or may not be condition. Now, artists are frustrated. Artists are frustrated. See, first of all, where is frustrated people? That is inside DL likely, not sure. So any conclusion with respect to frustrated people here would be likely only, would be possible, but not 100% conclusion. Then B option, some drug addicts are whimsical. Okay. Now listen here. Okay. What about these people? Some artists are drug addicts. So these are, what is this? This is an intersection containing artists and drug addicts both. Okay, but any artist is also a whimsical. That means some drug addicts. These are some of the drug addicts which are common to artists and hence inside whimsical. So this is the correct answer. Some drug addicts are whimsical. Some drug addicts are whimsical. This is confirm. This is 100% confirm. Okay, again I'm telling you, any option with respect to frustrated people cannot be concluded. It is just a possibility. This may or may not happen. Whimsical people are generally frustrated. No, we cannot say that. Okay. Again, anything, whereas frustrated people, it is a possibility. It may be inside DR. Frustrated people may be outside all the three boxes here. Okay, B is the appropriate answer. Hope it is clear to you. B is the very, very appropriate answer. Okay, yeah. Geeta is prettier than Sita, but not as pretty as Rita. Okay. Okay, a basic arrangement question, one line arrangement question. What is they mentioned? What they mentioned in the question? Geeta is prettier than Sita. So in the sequence, Geeta is prettier than Sita, but not as pretty as Rita. That means Geeta is less, not as pretty, means less prettier than Rita. Okay, so Rita will be more prettier. Okay, or I'll write this way. I'll write this way. First, Geeta is prettier than Sita. So G greater than S, but not as pretty. Geeta not as pretty as Rita. So Geeta is less pretty than Rita, or R greater than G. This is the correct sequence. Sita is not as pretty as Geeta. Then what is the correct? Sita is not as pretty as Geeta. Correct. Sita is less pretty, not as pretty as Geeta. Option number A itself is correct. But you read the others also. Rita is not as pretty as Geeta. No, Rita is the prettiest of all. Okay, B option. Sita is prettier than Rita. Wrong. Sita is least. D. Geeta is prettier than Rita. Wrong. Geeta is less pretty than Rita. Option number A. Option number A. Done. Okay, so direction for the 3 questions. Okay, this is the direction and 3 questions. I have 3 questions are there. I'll just check it out. Yeah, all the 3 questions I have taken here. All right, yeah. So, 3 questions based on the same statement. What is there? 7 cricket players A, B, C, D, E, F, G are to be honored with Arjuna Award, okay, at a sports function, okay. The players will be seated on the dais in a row. The players will be seated on the dais in a row, okay, on a stage. Okay, A and G have to leave the function early, so they must be seated at the extreme right end. What I will do is, based on the statements, I will keep drawing the pattern here only. 1, 2, 3, 4, 5, 6, 7. 7 players are there. Okay, and what was the first statement? A and G have to leave the function early, so they must be at the extreme right. Okay, so who will come up here? Okay, at these 2 places, who will come up here? Okay, A or G. Okay, whether A right or G extreme right, that we don't know, but last 2 places, right 2 places for A or G. Okay, so they must be seated at extreme right. B will receive the best trophies, the best player trophy and mess at the center. At the center, so 3 here, 3, this is center. B is at the center. Clear? B is at the center. Okay, C and D are rivals and therefore must be seated as far apart as possible. C and D are rivals as far apart. Now see, C and D cannot come up here. Okay, so first of all, as far apart as possible, that means one of them should come up here and the other, these 2 are already occupied, the other could be here. Okay, or vice versa. I mean, these 2 places, I'll write down here, these 2 places are the places where C or D will come. Okay, where C or D will come. Okay, now, which of the following pairs cannot be seated together? Okay, which of the following pairs cannot be seated together? B and D. Possibility is there. Right? D comes here, B and D. Okay, it can be. Which of them cannot be seated together? You have to figure out which of the pairs cannot be seated together. D and G. It is again possible. D here and G here. Okay. Then B option. C and F. Okay, C and F. Sorry. This is also possible because F is missing here. So if I take C here, if I take F here, they can be seated together. No harm in that. E and A. Yeah, that is confirmed. Okay, A, is this side. Here C or D, so definitely A or G is here and E is somewhere here. Okay, these 2 are for E or F. So E is somewhere here. So E and A cannot be together. That is for sure. E and A cannot be together. Now I told you 3 questions on the same data they have asked you. On the same data they have asked you the 3 questions. Right. So let's move ahead. Okay. Same statement, only read the question now. 95. Which of the following pairs cannot occupy the seats on either side of B? Which of the following pairs cannot occupy seats on either side of B? Okay, either side, left and right of B. Okay, which of the following pair cannot come? Okay, option number A, F and D. Option number A, F and D. You look into this one. Okay, you look into this one only. F and D. Okay, now this is possible. D can come up here. As I told you already, I'll mark this once again, that who are the persons left? These 2 are for E or F. Okay, so yeah, F can come up here, D can come up here. So that's the correct answer. I mean, that cannot, which of them cannot occupy it? So they can occupy. Option number B, D and D. D and D. This is also possible. E coming here, D coming here. This is possible. We have to find cannot occupy. E and G. Option number C, E and G. Okay. So, E and G. E and G definitely cannot occupy. G cannot come up here, na? Either side of B, G is not possible, E is possible. So, E and G is one pair which cannot be on the either side. Okay, so option is E and G. Okay, E and G, that is option number C. D also I will explain you. C and F. Okay, C and F. Let me explain you C and F. Okay, now see, this is again possible. F may be here and out of C or D, C may be here. So, C and F is a possible pair. Okay, so option number C is the correct. Okay, one more question on the same data, number 96. What is there? Which of the following cannot be seated at either end? Okay, cannot be seated at the either end. Either end means left hand or right hand. Okay, which of the following cannot be seated at either end? Okay, now see. Okay, first let me read the option. What is the option? C, person C. Okay, no, C can be seated here. Okay, C can be seated at one of the end, no harm. Next option. What is the next option? Okay, person D. Okay, person D. Okay, let us check. Again, C or D. D can be here, no problem. At one of the end, D can be there. Okay. Okay, which of the following cannot be? Okay, cannot be seated at either end. Then option number C is person F. Yeah, very clear, na? These are the two places for F. E or F. Okay, will come here only. So F cannot come at any of the ends. F cannot come at any of the ends. Sorry, I have to go forward. F cannot come at any of the ends. Option number C. Option number C, correct. Okay, then what is there? Next question. 4 political parties, okay, W, X, Y, Z, they have decided to set up a joint candidate for the coming parliamentary elections. Four different parties are there, but they have decided to set up a joint candidate. Okay, they have decided to set up a joint candidate for the upcoming parliamentary election. The formula agreed by them was the acceptance of a candidate by most of the party. That is, a candidate should be accepted by most of the parties. Okay, for I think this has to be 4, F-O-U-R. 4 aspiring candidates A, B, C and D approached the parties, okay, for their tickets. Okay, now who is acceptable by which party, that is mentioned. A was acceptable. Okay, so I'll clearly write down a pattern here. I don't have any space here. Let me go here. Okay, 4 candidates A, B, C, D. These are the candidates mentioned. Okay, A, B, C, D approach the parties for their ticket. A was acceptable to W but not Z. A was acceptable to W but not Z. Okay, so acceptable by W but not Z. Okay, not Z means I will cross it. Okay, not by Z. Okay, then B was acceptable to Y but not X. B was acceptable to Y but not X. Then what is the next statement? C was acceptable to W and Y both. C was acceptable to W and Y. Next, D was acceptable to W and X. Next, when a candidate B was preferred by W and Z. Now B was, see, one is acceptability and one they are preferring, but no problem. The condition was acceptance of a candidate by most of the party. When candidate B was preferred by W and Z, candidate B was preferred by W and Z. Okay. Candidate C was preferred by X and Z. Candidate C was preferred by X and Z. Okay, and candidate A was acceptable to X but not Y. A was acceptable to X but not Y. A was acceptable to X but not Y. Not Y. Y cancelled. Okay. Who got the ticket? You see and you just decide who got the ticket. Okay, definitely C. Definitely this guy is C. Because this is preferred and acceptable by all 4 parties. Not only most, but actually all 4 parties. Okay, so the candidate C, option number C. Okay. I told you that there are some 4 or 5 questions on this basic puzzles, mapping. Okay, we also call it as mapping. Okay, which candidate preferred by which party. We're just trying to map, making down the list. Okay, next question. And this is important in almost every competitive exam. Such questions, so basic puzzles questions are important wherever the reasoning is a part of the syllabus. Okay, whether you talk about GATE or even ISRO or any other AE exam as well. 3 persons ABC, again this is mapping, persons and shirts and pants. 3 persons ABC wear shirts of black, blue and orange color, but not necessarily in the order. That order you have to map. Okay, and the pants of green, yellow and orange, again not necessarily in that order. No person wore shirt and pant of the same color. Okay, so shirt and pant cannot be of the same color. That is another condition. Further, it is given that A did not wear the shirt of black color. Okay, so let us write down here. There are 3 persons, A, B, C. Okay, and let me write down the shirt color and let me write down their pant color here. The simple mapping we will create. Now you see, when you read this, go to the statement number 5. B wore pants of the orange color. B wore pants of the orange color. Okay, so B wore pants of the orange color. That is fixed. Okay, so he cannot wear the orange shirt. Then Okay, so now let's come to A did not wear the shirt of black color. Now you see here, okay, orange cannot come up here. Okay, so orange can be here or here in the shirt cases. A did not wear the shirt of black color. B did not wear. Okay, so you know B orange shirt cannot come, same color not allowed, and also they are mentioning B did not wear shirt of blue color. So only possibility for B, not blue, not orange. So what is the third color of the shirt? Is black. Okay, black, blue, and orange. Okay, so here what you get is black. Okay, so second statement done, and A did not wear shirt of black. Okay, that is already satisfied. Okay, A did not wear shirt of black. Okay, so this is also sorted. Okay, then C did not wear shirt of orange. Okay, C shall not wear orange. So orange comes up here. Okay, and C will have blue. Okay, this is also done. Okay, A did not wear the pants of green color. A did not wear green. Okay, so green goes here. And what is the other color of the pant? Green, yellow, orange. Yellow comes up here. Okay, so what were the colors of the pants and shirts worn by C respectively? You see, shirt, pant and shirt in the sequence. Pant color and shirt color. Okay, so green and blue. Green and blue, green and blue. Option number B. Simple, huh? Okay, green and blue. Just see, only mostly you have to have the patience to read the data. Sometimes what students will do in such question, it looks like a big passage question. Okay, but when you start solving it, it is solvable. Within a minute or so, it is solvable. Okay. Maybe it takes few more seconds, more than a minute, but no problem. That is the balance will be created in the exam. There will be many questions which you will directly take mark. So that balance will anyways come up. Need not worry about that. Okay. Need not worry about that. This was also used. Okay, going to the next one now. Yeah. A question paper must have a question of one of the 8 poets. Must have a question, okay, from one of the 8 poets. It should be something like this. Must have a question from one of the 8 poets. A, B, C, D, E, F, G or H. Okay. First 4 belongs to medieval period, while the rest 4 are considered modern poets. Okay, first 4. Okay, so I'll write down this data here. A, B, C, D. Okay, they are mostly of medieval period, while the rest E, F, G, H, these are mostly the modern ones. Okay, the first 4 the medieval, rest 4 are modern. Then generally modern poets figure in the question paper alternate years. Okay, modern paper will figure in the question paper in alternate years. Okay, generally those who like H like G also, those who like F they like E also. The paper setters do not like to ask about F, as he has written books on F. I mean, the paper setters, this statement implies that paper setters itself have written, books on F. Okay, so they do not like to ask about F. Okay, but he likes F. They like F, but they do not like to ask about F. Okay, but they like F. See, liking the poet, but not trying to ask the question onto it. Okay. Last year, the paper contained a question on A, that is medieval. Last year, the question paper contained a question on A. But then, modern poets, okay, figure in the question paper every alternate year. Okay, so if the paper last year contained on A, okay, A is medieval. Okay, so current year if I say, then modern poet should come. Modern poet. So answer has to be from the modern poet. That is a very big hint. Okay, the answer has to be from modern poet. On the basis of information given, this year paper, okay, is most likely to contain the question on. Okay, modern poets, number 1. Okay, so not C. Okay, not C. Okay, now modern poet means E, F, G, H. Okay, E, F, G, H. Okay, then very clearly mentioned the paper setters do not like to ask about F. Okay, so they are not going to ask about F, but also mentioned, okay, he likes F. Okay, but they are not going to ask the question about F. Okay, right. So answer is not going to be F. Okay, but there is one more statement. Those who like F, they like E also. So if they like F, they are not going to ask about F, but if they like F, they like E also. So most probably they can put up a question from the poet E. Okay, poet E. Okay. Okay, from the poiety. That's it. Okay. Anyways, next question. Yeah. In a group of 6 women, there are 4 dancers, 4 vocal musicians, 1 actor, and 3 violinists. Again, mapping. There are some set of persons, and some of them are dancers or musicians or etc. Okay. Now let me keep, and in all such mapping question, keep a clear-cut relation. Okay. Let's write down. There are a group of 6 women, and what are the 6 women's? Okay, the names are coming up into the action. Girija and Vanaja. Okay, I will say Girija as G, Vanaja as V, then Jalaja as J, Shalja as S. What are the other names? Shalja, Tanuja as T, any new name? Pooja as P. Okay, so these are the 6 persons. Who are the 6 persons? 6, na? Yeah, so these are the 6 persons or 6 women. Okay, respectively they are named as GV. I'm writing short only, GV. Then you have Jalaja, Shalja, JS, Tanuja T, and Pooja P. These are the 6 women. Clear, everybody? These are the 6 women. Now, Girija and Vanaja are among the violinists. Okay, so I'll call the violinist as V. Dancers will be known as D. Vocal musicians will be known as VM. And actor will be simply named as A. Okay, so Girija and Vanaja are among the violinists. V and V. Okay, then while Jalaja and Shalja do not know how to play violin. Okay, so Jalaja and Shalja will not be violinists. Okay, then Shalja and Tanuja are among the dancers. So Shalja and Tanuja, dancers. Okay, then Jalaj, Vanaja, Shalja and Tanuja. These 4 are vocal musicians. So 4 vocal musicians are sorted. JVST. Okay, JVST. These are all vocal musicians. Okay, these are all vocal musicians. Then Shalja and Tanuja are vocal musicians. Okay, that is clear. And 2 of them are violinists as well. 2 of them are violinists. See, 2 of them. Out of these 2 are violinists. This is violinist. Okay, and then one more statement mentioned about violinist. What was that? Jalaja and Shalja do not know how to play violin. So J and S cannot be violinist. J and S cannot be violinist. This is already violinist. So Tanuja has to be violinist as well. Okay, then if Pooja is an actor, and there is only one actor, so Pooja is in the actor category. Okay, that is done. Okay, who among the following is certainly a dancer and violinist? Okay, have we got the answer up to this time? Who among the following is a dancer as well as violinist? D and V. Here is your answer. Dancer as well as violinist is the person T. T was for Tanuja. Option number D. That's it. This is what it is. Okay. That's it. These are all the 30 questions done. Okay. Of course, for me to describe you, of course, I'm right. There are several things which you can solve orally, but I am writing for your solution, for your understanding case. It might have taken, say, roughly approx 1 hour or little more than 1 hour to explain you these 30 questions, okay, to read, to describe you, okay, but alone, I think on an average 30 to 40 minutes of time, if you are again into a good practice of aptitude. Okay, maybe you're not able to solve 30, but easily you can crack 25 in the exam time. Around 24, 25 easily you can target. Okay, in a 30 minutes of span of time, 30 to 40 minutes, let's say. Okay, so I think, yeah, that's what you have to target. But again, this will only happen if you are into the good practice. That is most important thing. You have to be in the good practice. Okay, so keep practicing up till the notification is there. See, aptitude is something you should not give entire day or several days to it. Because you have a lot of burden of technical subjects, huge syllabus is there, but this is some subject which is important. See, this time maybe it is 30% weightage or it may be 20% also, but either 30 or 20, both are very, very heavy weightage. Okay, so anyways, it is important, but at the same time, even if you daily spend 30-40 minutes or 1 hour based on your availability and bandwidth, some 30 minutes to 1 hour you put a daily and keep practicing one day, one small topic, you will be into good flow because the topics are endless. Okay, yeah, important topics everybody knows, so keep practicing and set a daily routine 30 to 1 hour. That is enough, I think, for this particular subject. Okay, so yeah, thank you for watching this video. And yeah, so we have completed the complete paper discussion for AP Transco 2019, and yeah, hope you have understood. And got the complete solution. And also, you must have got the clarity how the level of the paper was, including aptitude, and technical. Like in technical, all of us discussed different subjects. I took app control system also, which was relatively easier only. Okay, so yeah, that's it. Okay, bye bye, thank you, and stay subscribed to OHM Institute, because many such paper solutions and many other videos for GATE as well as AE, okay, will be available, okay, to help you in your preparation journey for GATE, AE, engineering services, PSU, ISRO, all such examinations. Thank you and take care of yourself.